Brothers, please be seated. Ladies and gentlemen, we continue to the next agenda, reciting a prayer by Bapak Gustarnali MT. Time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Alhamdulillah, the words shall be spoken apart from the gratitude of the presence of Allah for the blessings given to us all, so that we can gather in this room are learning and daring good health. Salawat and greetings to our Prophet Muhammad. On this occasion, allow me help to lead prayer in Islam and for non-Muslim. Please pray according to your respective belief. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Hamdan syakirin hamdan na'imin. Hamdan yu'afini amma yukafihu mazida. Ya Rabbana walakal hamdu kama yanbaghi li jalali wajhikal karim wa azimi sultanik. Allahumma a'inna ala zikrika wa syukrika wa husni ibadatik. Allahumma inna nas'aluka ridhaka wal jannah wa na'udzubika min syahhatika wan nar. Allahumma inna arinal haqqa haqqa warzuqna tibaa wa arinal batila batila warzuqna tinaba. Allahumma innaka afun tuhibbul afwa fa'fu anna ya karim. Ya Allah, most merciful and most always. Today, Monday, 18 October 20 and 21. In this event, we gather here to join Hall on International Seminar with the title is Microwave Remote Sensing to Technology Education, in collaboration with World Class University in program Kompetisi Kampus Mandiri PKKM of Marine and Department University of Bangka Belitung. Ya Allah, most source of all goodness, make this international seminar organization today beneficent to our life, like the sun on the earth, and our knowledge lead us to become productive people who are successful in the future and share the benefit for all. Ya Allah, God to right path, give us patience, health, and protect us from the spread of the COVID-19 pandemic, and may this COVID-19 pandemic end soon for all. Rabbana taqabbal minna innaka antas samiul alim wa tub alaina innaka at-tawwabur rahim. Rabbana afriq alaina sabran wa sabbit aqdamana wansurna 'alal qaumil kafirin. Rabbana hab lana min azwajina wa zurriyyatina qurrata a'yun waj'alil muttaqina imama. Rabbana hab lana min azwajina wa zurriyyatina qurrata a'yun waj'alil muttaqina imama. Rabbana hab lana min azwajina wa zurriyyatina qurrata a'yun waj'alil muttaqina imama. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Subhana rabbika rabbil izzati amma yasifun. Wassalamu ala mursalin walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Bapak Guskarnali. Ladies and gentlemen, now we continue to the reporting speech delivered by Mr. Aditya Pamungkas, the lecturer of Marine Science Department, Faculty of Agriculture, Fishery and Biology, Universitas Bangka Belitung. Please welcome Bapak Aditya Pamungkas.
Good morning, ladies and gentlemen. My best wishes to all of you. To begin, I would like to greet the Honorable Rector of Universitas Bangka Belitung, Dr. Ibrahim MSI. I also would like to greet all the vice rectors, deans, head of agency, lecturers, and students of Universitas Bangka Belitung. And the most important, I especially greet our keynote speaker, Professor Josaphat Tetuko Sri Sumantyo, PhD, from Chiba University, Japan. Distinguished guests, allow me to represent the head of Marine Science Department, Ms. Eva Utami, and also express my gratitude to the execution team of this international seminar, Ms. Revi Safitri and team, who were exceptional in their designing, preparing, executing of this international seminar with title Microwave Remote Sensing Technology and Application. This international seminar is part of program Kompetisi Kampus Merdeka grants from Ministry of Education, Culture, and Higher Education obtained by Marine Science Department to implement Kampus Merdeka curriculum. This curriculum create innovation to improve the quality of universities in several aspects, such as of campus student learning activities, professional certification for students, and collaborating with world-class universities, much like today, as we are having this international seminar together with Chiba University. Collaborating with world-class partners create the opportunity for universities to involve in the international sphere of education, research, and community service. For the Marine Science Department of Universitas Bangka Belitung specifically, this international collaboration is an important step toward the international accreditation that we are targeting to obtain in the next 3 years. Today, international seminar is follow-up of the MOU between Universitas Bangka Belitung and Chiba University by presenting the incredible Professor Josaphat Tetuko Sri Sumantyo, PhD, an expert in microwave, satellite, and remote sensing. I once met Professor Josaphat Sensei at Chiba University around 2015 and was very amazed by his laboratory, namely Josaphat Microwave Remote Sensing Laboratory. And I also very amazed with the excellent knowledgeable student and researcher who work under his supervision related to microwave and remote sensing. The application of microwave and remote sensing technology itself could be the best option, especially in archipelagic regions such as Indonesia and Bangka Belitung province, which has limited option for exploring its territory when using conventional methods. Therefore, today we would like to present Professor Josaphat, who can provide us with some insight into the development of microwave technology and its potential application in our region. Finally, I would like to say, may this international seminar lengthen our horizon, and we could directly involve in the transfer of knowledge from the world-class campus, such as Chiba University. I hope this activity is a first step in a long journey of collaboration between Universitas Bangka Belitung and Chiba University, especially with Professor Josaphat at several activities in the future, such as student exchange program, joint research project, and other scientific activities. Once again, I would like to express my gratitude to Professor Josaphat and Chiba University for sharing their knowledge with us in this international seminar, and hopefully we can meet face to face and keep collaborate in the future. To the audience, I welcome all of you to exchange your insight and knowledge during this international seminar, and may this seminar be a great learning experience for all of us. Thank you, and please enjoy this international seminar.
Okay, Please, audiences, give applause to Mr. Aditya Pamungkas. Thank you, Mr. Aditya, for the speech. Excellency, participants, ladies and gentlemen. So now we're going to listen to the opening speech delivered by Rector of Universitas Bangka Belitung and officially opened the International Seminar 2021. Please be invited, Dr. Ibrahim, MSE. Time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrabbilalamin. Wassalatu wassalamu ala asrafil anbiya'i wal mursalin. Sayyidina wa maulana Muhammadin wa ala alihi wa ashabihi ajma'in. First of all, let's say hamdalah. Alhamdulillahirrabbilalamin. Thanks to God for everything that given to us. Our faith, our diligence and active is always come from Him, and that's why we have to always thanks for His barakah. The respected guests for our international seminars, our keynote speakers from Professor Josaphat, Sensei Josaphat Tetuko Sri Sumantio, Head of Environmental Remote Sensing, Chiba University, Japan, and also our moderator today, Assistant Professor Raden Priyoko Prayotno Adi, PhD, Head of Electrical Engineering, Bangka Belitung University, and also the respected guests today, the Dean in the faculty in the University of Bangka Belitung. There is Bu Diana, the Dean of Faculty of Politics and Social Sciences, and Vice of Dean Bu Dr. Dita Prapti Rahayu, and also Head of Departments, and also maybe the Dean of Faculty of Agriculture, Fisheries, and Biology by online, and all audiences. Thank you very much for joining us today. I think discussing the main topic of our seminar today, microwave remote sensing and technology and applications, seems relevant at least two aspects. First, it's relevant to the technology and application that develop in scientific activities in our education system. Using the new technology is not only our necessity, but also the quality of life, and finally, in line with the disruption era. The disruption era technology, in disruption era, as we understand that technology needs to be adapted in terms to enrich the quality of life, and finally also enrich our education system. We realize that using technology will be guarantee for us to join in highly competition, global, and also in regional area. Remote sensing technology in practical needs will help us to anticipate many things like a disaster, underground dynamics, and also to predict the search and rescue. In Indonesian word, we understand that SARS, search and rescue. The finding of technology also will be very useful to help government in planning the policy formulations. Well, secondly, the topic is also relevant with our discussion on Merdeka Belajar, Kampus Merdeka model. This is the program is also, I think, kind of what we call MBKM. In MBKM program, we place the idea, practical and also theories in one formula to shape our graduates' profile. By this seminar, we can start to think how to use the technology in solving the real problem. In Bangka Belitung province, our problem is underground tin mining by people that sometimes have a problem in searching and rescue the miners. Kita tahu bahwa ada beberapa kecelakaan kecil misalnya karena penambangan timah. And sometimes we have problem how to rescue and how to search them. On coastal area, we have a problem to monitor the line of mining and non-mining area when the vessel suction, kapal isap produksi, operate in beach and coastal area. Sometimes we have problem also to anticipate the flood as the impact of mining. Maybe by these seminars, we can learn and deal on how to make the new connection with the world-class university, like a Chiba University, also solve our practical problem in Bangka Belitung Islands. Ladies and gentlemen, as a young university, we do need as many as partnership as a source of our connection. We are located in an islands. Many people maybe not understand our existing as a new university and also as a young university, but by the international activities, we will have an opportunity to accelerate our development. So we thanks to Professor and Sensei Josaphat for your friendly communication with Bangka Belitung University, and hopefully this seminar will be the beginning of our partnership, and one day you can come to Bangka Belitung University and we are able to share our academic benefit each other. Well, thanks also to Marine Department, Faculty of Agriculture, Fisheries and Biology in organizing the program under PKKM programs as Marine Islands. We call Marine Islands. I do hope this department will explore as many as our island potential, and I think this competitive advantage will guide us to create the advantage of our university. Don't forget that in our Mars songs, there is a word kelautan, marine. That is the first word that mentioned to show our academic advantage. So I hope all the lecturers and students in this department will understand that so many hopes for this department in developing our university advantages. Thanks also for the deans and all departments and our college to assist in these programs. On behalf of Bangka Belitung University, thanks again for all of you, the speakers, the moderators, and also our college from different departments in Bangka Belitung University, and all students and participants, and also our partner from others university, as what Bu Dini said, confirmed to us that there are some lecturer also from other university in Indonesia that join in our conference, our seminar today. Enjoy the seminars, and finally, there is a pantun for all of you. Di Jepang bunga sakura, di Bangka ada ketuyut. Selamat berseminar untuk kita, insya Allah kerjasama terus berlanjut. To start our international seminar today, let's say Basmalah. Bismillahirrahmanirrahim. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Mr. Ibrahim, for the valuable insight to us. So, ladies and gentlemen, jump to the next agenda. We would like to present to you a video of Universitas Bangka Belitung's profile to explore more about our lovely blue campus, UBB. Ladies and gentlemen, we're now continuing our agenda to the main program, that is to hear the keynote speech, which will be delivered by Professor Josephat Tetuko Sri Sumantio, PhD, from Josephat Microwave Remote Sensing Laboratory, Center for Environmental Remote Sensing, Chiba University, Japan. The keynote speech will be moderated by Mr. Raden Priyoko Prayitnowadi, PhD. So without further ado, please welcome Mr. Raden Priyoko Prayitnowadi, PhD. Let me introduce him to you. Mr. Priyoko has graduated from Manufacturing Engineering Manufacture Polytechnic, Bandung Institute of Technology for his bachelor degree. He continued his master degree on Manufacturing Management, University of South Australia, Adelaide, Australia. For his doctoral degree, he studied human factors in Engineering University of Nottingham, United Kingdom. His expertise are in manufacturing processes and ergonomics. So, Mr. Priyoko, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Ms. Dini Bulansari. And I'm Priyoko. I will be a moderator of this session. Before we go through the presentation from Professor Yosafat, I would like to check if the Professor Yosafat, are you there?
Yes. Oh, hi. I'm here. Yeah. Thank you very much.
All right. Thank you.
Yeah.
Well, if we talk about the microwave remote sensing technology as a general, I will ask to MC first. Do you know what is the remote sensing or microwave remote sensing technology?
Actually, I ever hear before about remote and also, yeah, let's say something that we use to turn on the TV, for example, and also, I don't know, sensing. It's kind of feeling, right?
Yeah.
Sense. So if we combine or if we relate to the technology, so how could it be actually, Mr. Priyoko?
That's why I don't know too. So if we again talk about remote or microwave remote sensing technology, all of you in here in this room, I will ask you in general, what is actually microwave remote sensing? Do you know or no? Well, if you talk about microwave, in my mind, microwave is an apparatus or machine that can heat up your meals, right? You can heat up your milk, your Indomie, or anything else. That's a microwave. And how about remote sensing then? Yeah, just like Dini said, I know remote control. Yeah, at home we have an aircon or TV set and equipped with the remote control. And what is the remote control then? Well, it is an apparatus, something like that we can push the button if you want to make on and off your TV or on and off your aircon, increasing, decreasing volume, for example, or increasing, decreasing brightness, loudness, something like that. You can control the TV set from far away, right? So far away means remote is a a distance between TV set and yourself. Yeah. So you can control something from far away. That's what I thought about remote control. Now, how about remote sensing then? Sensing, we know remote already. And how about sensing? Sensing, the basic word of sensing is sense, feeling that you said. Can you feel from far away? But it is technology. So that's why this is a general question from us, not from me, but also for you in this room and also in the Zoom room. Yeah. So I think this general question will be answered with one and only speaker today, Professor Yosafat. And I will introduce you first about Professor Yosafat. You can also see on the screen here the curriculum vitae of Professor Yosafat Tetuko Sri Sumantyo, PhD. Well, he graduated Bachelor Engineering from Department of Electrical and Computer Engineering, Kanazawa University, Japan, and then continue with his Master of Engineering from Graduate School of Electrical and Computer Engineering, Kanazawa University, Japan, the same university, right? And then he graduated from Center for Environmental Remote Sensing, Graduate School of Science and Technology, Chiba University, Japan, for PhD. He also has a Yosafat Microwave Remote Sensing Laboratory, Center for Environmental Remote Sensing in Chiba University. Look at the photo. He's very handsome, right? And actually, he's 2 years younger than me, because he was born in Bandung on June 25th, 1970. So 2 years younger than me. Okay, that's the brief curriculum vitae of Professor Yosafat, and I think I can call him Prof. Yo. Yeah, Prof. Yo. Well, before we go through the presentation, I would like to give you some information, ground rules of this presentation. Yeah. After Professor Yo finish his presentation, we are going to the question and answer session. Yeah. All of you in this room and also in the Zoom room can send the question directly to Prof. Yo. How? Well, in this room, you can raise your hand and I will give you an opportunity to directly ask to Professor Yo. And for the Zoom room, the audience from the Zoom room, you can send your question to the specific link that the committee has already sent to the chat room on the Zoom. Yeah, you can click on it and then write it down, your name, underscore, your institution, underscore, and your questions. Yeah, and interestingly, at the end of this session, we have a door prize. Yeah, so ask as many as possible. Yeah, so just now, sit down, relax, put your notes, make some question, and then after Professor Yo has finished his presentation, we will have a question and answer session. All right, I think all of you understand it. And for the door prize, it will be led by MC. So, Prof. Yo, are you ready to give him a presentation today?
Okay, no problem. Yes, I'm ready now.
All right, okay then. Now, Professor Yo, the screen is yours now.
Okay, yeah. Thank you very much. First to Bapak Priyoko Prayatnoadi, yeah, for your introduction of my work. Yeah. Okay. And first is I want to thanks to Dr. Ibrahim, Director of Universitas Bangka Belitung, and then also the Secretary Department of Marine Science, Dr. Aditya Pamungkas, and also Ibu Eva Utami, Ibu Revi Safitri, and also the MC, Ibu Dini Wulansari, I'm sorry, yeah, and also Mbak Siti Aisyah, who had some collaboration with our laboratory for a long time since she was the student at Universitas Diponegoro. Today, thank you very much for the opportunity for me to give the talk, yes, related about the microwave remote sensing. You can hear my voice perfectly?
Yes, it's clear.
Okay, yeah. Thank you very much. Yes, I use the headphone and mic. Yes, I hope can get the voice is more better. Yeah. Okay. Today I want to give a talk. Sorry, could you change the host to me? Yes, I want to share my slide. Yeah. Yeah. Okay. Okay. You can see my slide.
Yes.
Okay. Yeah.
Yes, sir.
Okay, perfect. Yeah, thank you very much. Today I want to give a talk, yes, related the microwave remote sensing technology and the application. But it's not just the side of the technology on the science. Yeah, I want to talk to about the study and research to become the world-class researcher. Yeah, I hope some of you, the young scientists of Indonesia, yeah, I hope in the future you can be the world-class researcher, world-class scientist, and I hope some of you also can get the Nobel, yes, Nobel Prize. Yes, this is our dream, but maybe we can do. Yeah. Okay. My name is Josafata Tukosdi Sumantio. I'm the professor in Center for Environmental Remote Sensing, Chiba University, and I manage the Josaphat Microwave Remote Sensing Laboratory, or GMRSL. You can find the activity of my research and some study of my student, as you can see in this website. And yes, I'm officially also the professor in Department of Teknik Elektro, yeah, or Electrical Engineering at Universitas 11 Maret in my hometown at Surakarta or Solo. Yeah, since last year. Yes. Okay, this is a brief of biography that already mentioned by Bapak Priyoko. Yeah, and actually, yes, I'm both the professor into university, and I'm also now from this month, yes, I'm also the head of the division of disaster data analysis, yes, in the Disaster Medical Research Center. It is a new center in Chiba University and under the Faculty of Medicine. Yes, you know that microwave can work for many fields, yes, including the medical. Yeah, so in this case, yes, I'm also one professor in the faculty of the medical in the medical faculty. Okay, and yes, until last year, I'm to be has the head department of at the environmental of remote sensing, and next year I'm to be the head of department again and also head of the division. I hope some of you can enroll to our laboratory on our department, especially next year, and I'm to be the head of department, and I promote some activity to learn about the remote sensing technology. It's not just microwave, but you can also consider about the optical remote sensing and also some of the sensor. Yeah, and yes, you can find many paper of me. Yes, from the journal of paper is this is right now is more than 130. Yeah, and also talk is more than 270, and also in the conference paper is I think more than 500. And books, I already published 15 books, and now I'm prepare another 2 books, yes, related my work, yes, circularly porous synthetic aperture radar. And yes, and also the activity of the IEEE. I hope some of you also can promote some paper, yes, especially for the IEEE Geoscience and Remote Sensing letter. Yes, I'm the associate editor of this journal. Yeah. Okay, yes, this is one of introduction. I'm one of the Japanese in Japan. Yes, it is in the scientist of the aerospace. You can find in the website of the Japan government of the cabinet office. Yes, it is in Indonesia is DPR. Yes, you can find I'm to be the representative of the aerospace scientist of Japan. Yes, it's not Indonesia. Yes, yes. Fortunately, yes, I'm yes. Why it's not Japanese? I think it's many Japanese the aerospace scientists, but I'm to be one of the representative of them. Okay, as the background of my family, my father is the Indonesian Air Force. Yes, he was the instructor of the Kopaska, Komando Pasukan Gerak Cepat, or right now is Komando Pasukan KAS TNI Angkatan Udara. Yeah, and I have the a dream to develop the radar for my father. Yes, this is my a pledge to my father when I'm 5 years old. Yeah, and you can find here. This is when I'm. This is my father. My mother. My mother is the the kindergarten. Yes, teacher and Klaten. Yeah, Klaten is in the Central Java. Yeah, and when I'm here's kindergarten, yes, and it here is when I'm elementary school. When I'm elementary school until third grade, yes, I could not read anything. Yes, so in this case is in the rank of my class is we had 23 students, and I'm the rank of 23. Yeah, this is in the the most lower rank in the class. Yes, but unfortunately, unfortunately, and after that is I learn much, and then I'm to be number one in the class, and after that is continuously I'm to be number one until I hope until right now in the especially in the field of the radar in the world. Yes, I'm to be the number one. Yeah. Okay, and yes, I spend my life at Solo. Yes, it is SMA Negeri 1 Surakarta or Solo. Yeah, close to Universitas 11 Maret. That now I'm to be the professor in there. Yeah. Okay, and then I got the scholarship from Pak Habibie, and I enrolled to Kanazawa University, and I got for the undergraduate from Habibie scholarship, and then after that from another scholarship from Japan, yes, from the master and doctor course. Yeah. Okay, this is my life. Yes, and then sorry. Yeah. Okay, and this is my father and also my sister. My sister is now to be on the top of the WARA, Wanita Angkatan Udara in Indonesia. Yeah, and this is my father. Yes, yes, he went to many battlefield, and yet fortunately, my father name is now is to be one of the building name in Lanut Adi Sumarmo, because my father is passed away in 2018. Yeah, yes. Fortunately, some of people is know about my contribution of my father. Okay, this is my books. Yes, many books. At least it's 15 books in several publisher like the Wiley and also Springer and also in Curator in Japan and IEEE too. And I hope next year is to be published one of the circularly polarized synthetic aperture radar books by the Francis and Taylor and CRC, publisher of at UK and United States. Yeah. Okay, this is my activity in Indonesia. Is I hope you can access in the YouTube. Just put Josaphat, yes, Josaphat and Kick Andy. You will find about maybe 1 hour, yes, 1 hour program of Kick Andy that talk about my life and what I got. My opportunity to develop some synthetic aperture radar for the drone or UAV, unmanned aerial vehicle, and then for the airborne SAR, and also for the satellite. Yes, because I developed also on the satellite. Okay, for you, now is the map. Yes, the map in the right now that it is in the knowledge, it is very large. Yeah, you can see here in the United States. I think you're familiar very much. Yes, and here in the Canada, and here in the Africa and Australia and China and Japan. Yeah, and here in the Russia. Yeah, and if we compare Indonesia it is in the real scale. Yeah, Indonesia and it is United States. Indonesia is more longer, except if we consider the Guam and Hawaii. Yeah, it is. But if we consider just the United States compared to Indonesia, it is more larger. Yeah, and then compared to the Canada. Yes, Indonesia is more longer. Yes, if you compare from the Vancouver to here in the Halifax. Yes, I went to Halifax in the the most eastern of the Canada. Yeah, and also here and the close to the Alaska. Yeah, Indonesia is more longer. Yes, it is more bigger. Yeah, so in this case, is you must think Indonesia with a big a big thinking. Yes, it is very important to consider Indonesia. Indonesia is not just small Java or small Sumatra, yeah, and small Bali island. Yeah, we are very big, and we need a very big thinking to manage Indonesia. And here in the Russia, yes, almost Indonesia and Russia is almost same. Yeah, and then if we consider compared to the China. Yeah, the China is this is from the Kyrgyzstan or Tajikistan, and then here in the South Korea and here in the Japan. Indonesia is more longer. Yes, because Indonesia is from Kyrgyzstan, Tajikistan until here. Yeah, here is close to the Hiroshima. Yeah, Hiroshima of the Japan. All of the China is included in Indonesia. Yes, so Indonesia is very big. Yes, a very big country. Yeah, and of course, if we compare with Australia, is same. Yes, we are is more bigger than Australia. Yeah, so and it is most I think it's very interesting. If we compare with the Europe. Yes. From the United States, United Kingdom, yes, until Kazakhstan, yes, it is almost all half of the Europe is just half of Indonesia. Europe is very small, but it's a modern country is over there. Yes, but you must consider right now why Indonesia is not modern country. Yeah, we are very big. We have the resources much. Yeah, it is the problem is in the human resource. Yes, so in this case is please learn much. Yes, and please consider the new thing. Yes, the new thing and original thing that only one. Yes, the only one born from Indonesia, and how to contribute from the world. It is you must consider right now. Yes, of course. Yes, we adopted many culture. Yes, we adopted from India, from America, and also from Arabian. Yes, from some religion. Yes, it is. But we must consider that it is all from the outside. So it's not from Indonesia. We need to consider the original one from Indonesia. Yes, then because the foreigner from outside of Indonesia, we just honor to Indonesia is to the what is the original thing from Indonesia. Yes, especially from young scientists and young student. Yes, please consider what you can contribute from the world. Yes, it is very important. Yeah. Okay, and yes, right now is what you want to contribute from the world. Yes, it is my a question. I hope please consider from right now. Yes, what you can develop, what your invention, and then what you can contribute from the world. Yeah. Okay, this is actually I'm already have many collaboration, including Universitas Bangka Belitung. Yes, actually I plan to visit Bangka Belitung 2 years ago, but unfortunately because of the Corona is now we pending. Yeah, I hope next year I can go soon to Bangka Belitung because I have some research. Yes, have relation with the Bangka Belitung. One of the research is about the old map. When the old map of Indonesia is the center of the the tight point or ground control point is at Bangka Belitung. That this point is very important that connect to the Southeast, almost all Southeast Asian country from the map, standard map in Southeast Asia that developed by the Netherlands and also the UK, France, and so on. Okay, and I also promoted the double degree program. It is with 6 university in Indonesia. I hope the Bangka Belitung University also some of you, especially the lecturer that who not yet get the master or doctoral degree. So please join us, and then you can learn in our center and university, and then you can get the master and a doctor degree. Yeah. Okay. Yes. It's not just the domestic, but we also promote the international collaboration with many, especially in the aerospace agency, because I developed the satellite for many countries, including the Korea, Taiwan, and also the Canada, yes, Canada, and also the Europe, yes, European Space Agency. One of the microsat is yes, I designed for them. Yeah. Okay, this is our center. We have many professors, and here is the advanced research on the remote sensing. It is one of the division that I'm head of this division. Okay, and the IEEE, you can see the instrumentation and future technology. It is some of the activity that we promote, and especially from the unmanned aerial vehicle. Yes, it is I'm to be the leader here. Okay, now I want to talk about what my research. Yes, I started the research in 1992. Yes, when I started learn in Japan. Yes, it is. I want to learn about the radar, and then I want to develop the radar by myself. Yes, it is because what I, it is what I said to my father. Yes, I want to develop radar for him. Yeah, and then it is my first radar. Yes, when I'm in the undergraduate or in the bachelor, I developed the underground radar. That underground radar can penetrate. It is 2 kilometer underground. Yeah, and like Bapak Rektor mentioned that mining is one of the main industry in Bangka Belitung. Yeah, in this case, is if you want to know mapping the mining, resources inside Bangka Belitung island, so you can use this underground radar. Yes, I developed this one. Is very simple, but this basic is the basic science for my further research. Yeah, and then I did the research. Yes, about the synthetic aperture radar when I'm here is in the master and doctor course. Yes, and then you can find some of the my theory. Yes, about the scattering. Yes, the scattering of the microwave. Yes, scattered from the pitland. Yes, because I want to estimate the thickness of the pitland. It is in the burn coal. Yeah, pitland is one of the young coal layer that it is very easy to to burn, and after the burn is very hard to extinguish. Yeah, because it is it's very depth. Yes, so in this case is we need some technique to know about the depth. So in this case is I promoted some technique like this one. It is my theory to know the scattering of the microwave, and then we can estimate the thickness. Yes, it is the data from the synthetic aperture radar that analyzed by my theory, and then you can estimate the thickness of the burn coal seam. Yeah, from the detail theory, and you can read my paper. Yeah, that published in International Journal of Remote Sensing and GSPRS. Yes, it is in the Japan journal. Okay, and the other one, then I started to develop some antenna for the ground segment, and also for the satellite. Yes, it is. I have the collaboration with here and ICT of the Japan. In Indonesia is ComInfo. Yes, the Minister of the ComInfo in Japan, and I developed for the mobile satellite communication. Yeah, all of the my invention, it is only one in the world. Yes, it is all is my original. Yeah, and then yes, fortunately I got many awards. Yes, from for my invention. Yeah, including this antenna. Yes, you can read my paper in IEEE transaction on antenna and propagation. Yes, related this invention, because before in the antenna for the mobile satellite communication is big, is very big, and if you put on the car, on the a ballet train, it is a big problem. So in this case is I developed the antenna is very thin, just 1.2 millimeter. Sorry, millimeter. Yeah, 1.2 millimeter. Yeah, and then we can operate this antenna for the dual band. Yeah, before it's just single band, and here is I invented dual band and very thin, and then you can put on the car and on the train. Yeah, and if you operate in Japan, yes, from the Hokkaido to the Okinawa, you can use my antenna, because my antenna is I designed to operate, to be operated in Japan. Yeah, so if you move in Japan, is you can work. Yeah, but if you bring this antenna to Indonesia, is you cannot use, yes, the antenna. And the other one is the antenna. It is from the microsatellite, is because we need to make the antenna is more smaller and it's very light. Yes, it is, and then the antenna is can be operated in the space. Yeah, in the space is the temperature is from -50 to 100 degree. It is very hot. Yes, and this is and then also the influence of the radiation, the space radiation on the cosmic radiation is also big influence. Yeah, so in this case is I developed many type of the antenna from the space environment. So in this case, in Japan, in Chiba University, we have 2,400 professor. Yeah, in Chiba University, and university made the selection and to choose the professor that doing the advanced technology, and fortunately I'm to be one of the six selected professors here. Yeah, and you can see in the website of the Chiba University what I did. Yes, and here is it is in Japanese. I work for the remote sensing, especially for the microwave remote sensing. My work, I will retire in 2035. Yes, so I think I'm still have about 14 years. Yes, and then I want to realize my dream. Yes, to develop the sensor to know about the activity of the ionosphere and also the land deformation. Yes, using the sensor that I'm developed. Here is the sensor for to know about the total electron contents. Yes, and then the electron temperature, humidity, and so on. It is in the ionosphere. Yeah, because if we know the change on the distribution of the total electron content in the ionosphere, so we can mapping and then predict the earthquake. Like in Indonesia, we have the earthquake very much. So in this case, we need the sensor that can predict. Yes. So in this case, we develop many sensors to predict the earthquake and another disaster. And after the disaster happens, so post-disaster, so in this case is we want to know about the land deformation, like the landslide and also the active fault. Yes, so in this case is we need the very precise sensor. So in this case is I developed the circularly polarized synthetic aperture radar, or CPSAR. You can searching in the Yahoo on the Google, circularly polarized synthetic aperture radar. I think you will find first is my laboratory or my name. Yes, because is my invention. Yeah, so and this sensor, it can make the system is to be more smaller. Yeah, okay, and this is my roadmap. yes, I hope you and the student and young scientists, please have the roadmap of your life. This is very important to know. Yes, or to design your life. Yeah, life design is very important. Yes, if you have the target. Yeah. So in this case, is for example, next year, what is your target? And 2 years later is what your target, including the marry. Yeah, and you have the child and how to keep your family. It is also very important. Please make the roadmap. In this case, is I have the roadmap to launch 5 satellites. To launch, we need to make some experiment before, yes, including the flight of the, using the aircraft, and also develop some sensor, and also the ground station, like here in the ground station of my laboratory or GMRSL, you can find here. It is, we have a very complete facility in Japan. Yeah, and it is the technology that I'm already developed. Yes, I already developed some sensor, synthetic aperture radar, for the aircraft and UAV, and also the microsatellite. And this is our antenna. Yes, we have the collaboration with many institutions in Japan, Indonesia, and also in Europe, and also America. Yeah. Okay, and then what is the application of my, my invention? You can see here, my sensor can penetrate the cloud, yes, mist, yes, and also can be operated in the nighttime. So in this case, it's 24-hour. You can operate my sensor, yeah, because if you use the optical sensor, it is just in the daytime. Yes, in the nighttime is you cannot operate, the optical sensor. Yeah, so in this case, is we need the 24-hour sensor. Yes, so like Indonesia, we can get a clear sky. Yes, Indonesia is in 1 year is just average is just 3 months. Yes, 3 months of the a clear sky. So in this case, is we have the chance to observe the Indonesia in a year is just 3 months. So in this is very short. Yeah. So this is better you use another alternative of the sensor. So in this case, is synthetic aperture radar that I'm already invented. So it is very important because you can operate in 24-hour, and you don't consider about the cloud. Yeah. Okay. So in this case, is you can operate to to observe the disaster and natural resources. Yes, this is also you can get, because my sensor can get at least three information. Yeah, the intensity. Yes, so you can derive the backscattering coefficient, and also some of the information of the scattering, and then the phase. From the phase is you can get the information of the land deformation on the change of the land surface. Yeah, it is very important when you want to observe the disaster. And then the other one is the polarimetric. Polarimetric information is very important to classify what the object on the on the Earth surface. Yeah, and okay. Just using this three information, you can employ for this many application, including the home security for the anti-terrorism mission. Yeah, because the microwave is not just for the to heating the food. Yeah, so in this case, is we can also penetrate. Yeah, penetrate the wall. Yeah, you can mapping what happened. The wall. Often the wall. Yeah, so in this case, is you can mapping for example the terrorist. Yeah, the terrorist. Where is the terrorist? Standing or lying. So in this case, is you don't need many bullet. Yes, the gun. Yes, you can just need one gun. Yes, and one bullet. Yes, to to what is weak the terrorist. Yeah, and the other one is for the infrastructure monitoring. So the infrastructure monitoring is here is like Indonesia. Now we built many new infrastructure. Yes, it is including the seaport and airport, and also the highway. So in this case, is especially in the highway. Yes, highway is like Japan. Yes, they built after 5 years is many area is landslide. Yes, and also sometimes it's the wreck. Yeah, crack. Yeah, the crack of the road surface. So in this case, is you can predict what will be happen in the future. Yes, in this case is you need the sensor that is very precise. So in this case is our sensor, we can mapping, and you can know about the change of the land deformation. It is with the accuracy is centimeter, and sometimes it's millimeter. So in this case, it's very precise. So you can predict. For example, here is what I did for the Malaysian government. Yeah, I observed the east-west highway and also the high voltage transmission line. Yes, the tower, and the tower is moving. Yes, in a year, for example, some centimeter or some millimeter, we can predict. Yeah, oh, this area is some millimeter is moved. Yeah, in this case, in the future is this. Tower will be, will collapse, and then the infrastructure, the highway will, crack and landslide. So in this case, it's like this one. Yes, it is on the Cameroon highland of the Malaysia. So we can predict that this area will, landslide happen, and then landslide happen. Yeah, okay. And the other one is the volcano eruption. We can also use this synthetic aperture radar to know the thickness of the the lava. Yeah, the hot lava and also the cold lava, the volume as you can predict. And yes, this is my technique, and I got the award, yes, from this technique. Yeah. Okay, and then it is my satellite. Yes, with the payload is 150 kilogram. Before is this satellite is the weight on the payload is more than 1 tons, more than 1,000 kilogram. But now I developed the technology that the sensor is to be more than 150 kilogram. Yes, and then the sensor itself is circularly polarized synthetic aperture radar. And yes, of course, I have the patent of this invention. And yes, it is my student and with my satellite, and my student is from Pakistan, Japan, and also from Indonesia, Brazil, Malaysia, and Germany, and many countries. Yeah, so in this case, I hope Bangka Belitung University also to be in the advanced university, and then many foreigner will come and learn in Bangka Belitung in the future. But we start, yes, from what we can do. Yes, it is very important that from your original one. Yes, please don't say about mengejar ketinggalan. Yes, I heard always Indonesian people is mengejar ketinggalan. No, please don't mengejar ketinggalan. Please do something new one. Yeah, it is very important. Yeah, because if you do something new, it is another people will come and learn to you, and another people will ketinggalan for you. Yeah, so it is very important. Yes, so please do the new thing and original thing. Yes, because especially we don't have so much money, yes, for the budgeting of the research and the study. So in this case, please use the budget is more efficient. Yes, just consider that something that original from your side. Yes, from the especially from the Bangka Belitung student and also the staff. Yeah. Okay, and it is actually sorry, it's not work. It is an NHK. Yes, but my satellite. Yes, that's so about very light satellite. Yeah, and it is my original ground station. All is original in my laboratory. All is from my head. Yeah, I consider by myself and I design by myself, and then of course when we develop is we need many help. Yes, to make the component, and then we develop in all in my laboratory. This is very important for you. Yeah. Okay, and then we also developed the expansor. Yes, it is synthetic aperture radar. You can see here, it is our original radar for the aircraft. And then the antenna also, it is our original antenna. And then we put on the Boeing 737 of the aircraft of TNI Angkatan Udara. Yes, and we did the flight test in Makassar. I consider, the research is due in Indonesia. It is very important to promote the Indonesia that many Indonesian people can do. Yes, it is also a positive message from the world. Yes, so I did the research. Yes, and I did the flight test in Indonesia, and also the some of my research with the object in Indonesia. It is also very important. Yeah, please do. Yeah. And yes, I did also the experiment at Yogyakarta. Yes, with here in the Academy Angkatan Udara, I use the Cessna here. Yeah, and I will show you later about the video. Yes, and for the detail, as you can read our paper in IEEE Aerospace and Electronic System magazine. This is the one of the paper here. Yeah, and then this is the my radar called the circularly polarized synthetic aperture radar from the C-band, yeah, with the center frequency at 5.3 gigahertz. And then we, this is our sensor, original sensor, and here original antenna, and then we put inside here, yes, on the radome of the CN235. I think you remember that the name of the first name is Tetuko is also my name, yeah, and this is also very important, yeah. Okay, and then it is in the first image, yeah, the first image, original image on the circular polarized in the world, yeah. It's very clear, yes, and if you zoom up, you can find inside the house, yes, also because we can penetrate the house, yeah. And then for the detail, including the theory and the system and the application, as you can read my paper, yeah, my paper in IEEE JSTAR, yes, it is published last January, yeah. And then for the another one is for the application is I hope shortly is will be accepted by the IEEE TGRS, yes, and will publish maybe is next year. Yes, it in the situation inside the CN235. Yes, I think it's very hard. Yes, we can do, and we have the idea, and then we manage by ourselves, and then we realize, and we did the experiment and flight, and we have many collaboration. Yes, many friend is very important. So all of you, please make many friends. Yeah, please don't do by yourself. Yes, I saw many Indonesian is just single fighter. Single fighter is sometimes it's good, but for the big project is impossible. So if you want to create a big project, please collaborate with many people. Yeah. Including in my case is with the TNI Angkatan Udara and Bapak Prabowo Subianto, and also Bapak Luhut, yes, and right now is also Pak Hadi, yes, and the Panglima, yes, TNI is also our friend, yeah. So in this case, it's very important, yeah. Okay, and in the world, yes, many airborne SAR, yes, it is like the Intermap, yes, United States, and then Dunia, and also the DRR, it is in the Germany, yes, and also this Memphis, it in the France, and NASA, yes, and also Australia, yes, and here is the Emisar, it in the Finland, yes, Onera, France, and here is the TNO is the Netherlands, and Japan, it is in the Mitsubishi and the JAXA, and here is the Canada, and yes, and Josaphat Laboratory. Yeah, Josaphat Laboratory even is very small, but we did the new thing. Yes, it is the just only one in the world. Yes, and here's almost same with the very famous, aerospace agency. Even it's very small, but we are proud what we do. Yeah, because it is our original one. Yeah, it is the CPSAR, circularly polarized synthetic aperture. All is the linear polarization, but I'm is the circular polarized CP. Yes, it is my original. Yeah, and just one. Yeah, and here is in Indonesia. Yeah, you can find here in the CN235. Yeah. Okay, and the other one is I also developed the UAV SAR. It is from the L-band. It is with my student here. Yeah, when we did the flight, yes, and we put here, and the shape of the sensor, on the UAV also original. You cannot find in the world. Yes, it is just one. And how to fly it, as you can see in the YouTube, and just put the GMLSL, Josaphat Laboratory UAV. Yes, and then you can find this our UAV. And I'm sorry, I cannot run this video. Yeah. Oh, you can. Yeah. It is when we did the take off and landing. Yeah. Yes, this UAV is in 2012. It is the biggest in Asia. You know, right now is many UAV, but it is our first. Yeah, the first in Asia, and the biggest one is from Yosafat Laboratory. Yeah, and you know, it is just dedicated for this synthetic aperture radar. Yeah, that we also developed. Yes, all is by our laboratory and for this UAV. Okay, and next I want to talk about the image processing. Yes, from the image processing is you know, it is the raw data from the, you know, synthetic aperture radar, and then you process the range compression, azimuth compression, and you can get the image like this one. It is the image of the Krakatau. Yes, Mount Krakatau. Yeah. And then from the data is you can extract the intensity, phase, and polarization. Yeah. And then, for example, from the phase is you can use the coherence analysis like this one. Yes, it is in the application is when we analyze the earthquake at the Central Java that happened in 2006. Yeah. And from the phase is in the red side, it is in the when the building collapsed. Yes, completely collapsed is the red one, and the other one is like the yellow or the blue. It is you know, half collapse or just a crack. Yes, it, you know, you can know about the map of the, you know, affected by the disaster. So in this case, if you want to help, is you can focus, yes, which area, and because you know, from the map is you can find the coordinate of this area. Okay, and the other one is the information of the phase. You can extract the differential interferometric SAR or DINSAR. Yeah. For the detail theory, as you can read my paper in IEEE TGRS. Yes, this is about this theory that you can use two images, yes, before and after the disaster, and then you can extract the change information. It is in the phase change. Yeah. In this case, is you can extract the change on the horizontal change and the vertical change. From the vertical change, it is the like the subsidence when subside, and also the uplift. Yeah, sometimes it's uplift, sometimes it's subsidence. Yeah, and also the land deformation. It is the horizontal deformation. So, for example, the landslide or the crack. Yeah, the crack of the fault is also in the horizontal change. Yeah, for the detail is please read this journal. Yes, my paper. And yeah, fortunately my paper, almost all of my paper is to be in the cover. Yeah, the cover of the journal. Yeah, it is one of my work. Yes, this cover of this journal too. Yes, how to work? Yes, using the synthetic aperture image. Yes, for example, when I observe the subsidence of the Lapindo, yes, it Sidoarjo, yes, the southern part of the Surabaya. It is two images, yes, that observed in 2007 and 2006. Yeah, and then you make the geometric correction, and then calculate the complex conjugate, and then multiply, and you can get the fringing of the interferogram. And then just remove the orbit pattern, and then you can get the information of the interferogram. Yes, from the interferogram, even is you know, is still including the some noise, but you can remove the noise, yes, using several type of the technique on the method. Yes, I'm also have one of my original method of to remove the filter, you know, the noise itself. You can read my paper in Canadian Journal of Remote Sensing about how to remove the filter. Yeah, using my my technique. Yeah, and then if you compare with the DEM before the disaster itself, for example, the subsidence in Lapindo, yeah, you can remove, and if no remove, as you can use this data from the DEM, digital elevation model. But if you remove and get the some change like this one, yeah, it is still in phase error. Yeah, so in this case is oh, this area is some area is moved, yeah. And then you can unwrapping, and you can get the sorry, the land deformation. In this case is the subsidence. Yes, subsidence in Lapindo area. Yes, here is the subsidence itself. Yeah. Okay, and for some application, it is the subsidence of Bandung City when I born here. Yes, at Lanut Suleman is because my father is the instructor in of the Kopasgat, yeah, OPGT. Yes, in this time, yeah, in Lanut Suleman here is unfortunately this area is also subsidized. Yeah, here in the yeah. Sorry, yeah. Okay, yeah. Okay, this is the subsidence area in Cimahi and Dayakolot, yes, and also at Ranca Ekek or Majalaya. Yes, you can use this technique too. Yeah, yes. Here is yeah, I got the award from the SAIS and also the IEEE. Yes, from this technique. Yeah, and then the eruption of the Mount Merapi. Yes, it is I extracted my use my technique. New technique is volumetric synthetic aperture radar that I observe the the thickness, yes, the change of the thickness of the volcanic ash, yes, and maybe you remember the Bah Marijan, yeah, Bah Marijan, passed away when this eruption, yeah, and caused by this one, yes, yeah, okay, and then okay, yeah. Yes, it is. So I got the best paper award. Yes, for this my technique. Yeah, and here in the Lapindo. Yeah, and okay, this Lapindo is yes. I estimated with the thickness is 2.4 meter. Yeah, and Jepang Pantau Lumpur Sidoarjo. It is my work. Yes, and you can read my name is here. Yeah, and then I made the estimation about every villages in this area is how many centimeter move, yes, or subside, yes, using the synthetic aperture radar. Okay, the other one is the permanent scatter interferometric SAR. I observe like the Jakarta, yeah, the sedimentation in the Jakarta. Why in the Jakarta born? Yes, geologically, yeah. I use this technique, my new technique, yeah, own technique, and then you can read my paper and IEEE GRSL, yes, about why in the Jakarta is subside and why in the Jakarta is enlarged, yes, and this is my estimation. In the future, noise. Jakarta built many infrastructure, but unfortunately, maybe less than 50 years, this area is to be it is to be in the land. Yes, so I think it's you don't need to build here as in the future is to be in the land. Yes, because the speed here on the sedimentation is 40 meter per year. Yes, to be increased the line. Yeah. Okay, and it is my work, yes, to observe the Jakarta city until Bandung and also the Bogor city, yeah. And here in the using the PS INSAR, you can estimate it the velocity, yes, the velocity of the subsidence of the Cimahi city. Here in the Cimahi city and the Dayakolot city, and here is close to the place that I born. Yes, it is Cimario, yeah. Okay, yes, and I implemented also the landslide at Malaysia. I work with the Malaysian government and also USM, Unit 10, and also MMU. Yeah, yeah, to observe the land deformation at East-West Highway and some of the infrastructure of the Malaysia. Okay, before I talk about some advice for you. Yes, it is because I invited by you is especially in the Department of Marine Science. Yeah, I want to show you about the application of some of the marine science. Yes, it is using the synthetic aperture radar. It is when I fly. Yes, using the our sensor at here is the short syllabus or Sulawesi, yeah, close to the Makassar city. Yeah, it is from the my sensor, and you can see, it is like the Karamba. Yes, Karamba you can observe. Yeah, even in the nighttime. Sorry. in the nighttime is you can observe using this synthetic aperture radar. It here in the Karamba. Yeah, in the nighttime I think you cannot see. Yeah, but if you want to fly and you want to mapping even in the nighttime, is you can use the synthetic aperture radar. Okay, and here in the mangrove area, close to the Pangkajene, yeah, Pangkajene area. Here in the mangrove area, it is the optical, and here is my sensor. Yeah. Okay, and here in Japan, using the JERS-1 SAR, yes, if you compare, you know, it is also in the Karamba, yes, close to the Hiroshima Bay, yeah, and you know, even like this one is at least as you can find the mapping of the object on the surface of the sea, yeah. And here the grids at Yunani, yeah. Here is the Karamba, circle Karamba, yeah. Okay, and here in the wakame, yeah, wakame is seaweed, yes, rumput laut, yeah, also the rumput laut, yeah, like this one is also in the rumput laut, because Japan is like nori in the rumput laut, yeah, maybe in the convenience store in Indonesia, like Indomart, is now you can find the onigiri, yeah, onigiri is, I think it's onigiri without the wakame on the nori is not onigiri, I think, yeah. Okay, yes, this is some application of the, and then the fish cultivation field, yes, like this one. Yes, it is the Karamba. Okay, I want just run, and then if we use the comparing the X band, L band, C band, yes, different frequency, the scattering is also different. Yeah, the X band and here in the L band. Yes, I think it's because the wavelength is different and the thickness is different. Yeah. Okay, and the other application is I want to show you about some interesting. Yeah, this is the, you know, the tsunami. Yeah, here is before the tsunami at Sendai. Yes, Tohoku. Yes, Fukushima. I think you remember Fukushima. Yeah, before the tsunami, here is the some Karamba. Yes, and after the tsunami, you know, you can see the Karamba is moved. Yeah, where? Yeah, the Karamba move. Yeah, it is based on the scattering, yes, of the synthetic aperture radar you can find here. All of the Karamba and also including some object of the, you know, from the city, including the houses and some infrastructure will flooding to the ocean. Yeah, and okay, and here is also the like the inner wave. Yes, I want to show you about the some application. Yeah, it is in the internal wave. Yes, so using the internal wave is you can find some interesting, yes, phenomena. Yeah, for example, if you want to go to this sorry, the atoll. Yeah, atoll here. Yes, I think it's it is close to the Taiwan, yes, Luzon, and here is the atoll. Yes, if you come from here, it's very dangerous. Yes, because the wave is very high. Yeah, but here is you know, you can see it is very, you know, smooth. Yes, smooth and very quiet. So in this case, it's very good. Yes, you can come from here. Yeah, and here is the Dongsa Island. It is right now in the China is built. Some of the facility here, yes. In the future, is I think is even right now is to be a political problem right now. Okay, and then you can use also to mapping, yes, the continual self and the tidal current, yes, using the synthetic aperture radar. Even the, you know, some phenomena on the seas, you know, here in the shore, yeah. So, but you can predict using some of the internal wave, and you can estimate about the depth, yeah, the depth of this object. Yeah, here's some type of the some internal waves based on the some you know, for example, in the Luzon Strait, yes, and also in the Dongsa Plateau, that you know, some of the island, yes, that I already showed to you. Okay, here's some internal wave, and you can see like this one. Yeah, it is in the Dongsa, and here some internal wave, and you can predict about the depth of this the sea floor. Yeah. Okay, and then the other application, it is like it is in the ship. Yeah, from the ship. For example, in the nighttime, if you want to tracking some of the illegal object, so in this case, you can using this synthetic aperture radar. Okay, this is some of the uh, image of the wave. Yes. Okay, and the other one is it is when application for to know about the object on the surface. Yes, in this case, it's the like the submarine. Yes, here in the submarine. Yeah, and if we use our eyes, is very hard. Yes, to know because in the even in the daytime, the submarine is in the black. Yeah, so in this case is from the space it's very difficult. So in this case you can use the synthetic aperture radar to observe the object on the surface of the ocean. Yeah. Okay, and okay, before I close my talk, I want to show you that from my work is I got many awards. Yes, almost all of my idea and invention all got the award. Yeah, and then it is about the circulation of my research and academic activity. Yes, if we have the idea, yes, if we have the idea, first is please register the invention. In this case, it's the patents. Yeah, if you have the invention, please patents. Please don't present to the paper on the presentation in the conference. Yeah, first is please consider the patent. I think in Indonesia it's very cheap. Yes, for the patents. Please patent it your your invention first. Yeah, after that is please submit for the peer review paper. Yes, in the journal. After that is if accepted is please present, because right now right now is very easy. Many people especially on the online. Yes, right now is many conference online, and many people it's very easy to copy. Yeah, to copy what you did. Yeah, so in this case is before you submit the patents, many people will patent it first. Yes, this is very dangerous. Yeah, in this case is your invention, please patents, and then a peer review paper. After accepted, please present in the conference. Yeah, and then you can contribute for the community. It is have the relation with the hilirisasi. Yeah, hilirisasi need some patents. So it is better you have the patent because it is your right. Yeah, it is very important to guard your right. Yeah, okay, and then write the books, and all of this achievement is will get the award. Even award is from another side, from another people. It's not from you. Yeah. So in this case, is if you do the best thing and you contribute for many people, you make happy people. Yes, it is very important. Yes, please make happy. Yeah, people. It is you will be happy. Made happy by another people too. Yeah, it is very important. And then all of this achievement is will give the a big research grant for you. Yeah. I have the experience. Yes, when I'm associate professor, I submitted many proposal of the research grant. Sometime in a year, I submitted 58 proposal. In 1 year is 56 weeks. Yeah, and I submitted 58 proposal. It means every week I submitted the proposal. But right now is after many people know about me and about my achievement, and many people come to me and give the budget. Yes, I don't need to find the budget, and the budget will come to me. Yeah, so in this case, it's very important. It is the most important is the trust. Yeah, the trust from many people is very important. Yes, so please keep the trust. Yes, and build the trust. Yeah, this is very important. Okay, and it is my advice for all of the student here. Yeah, especially the student of the Bangka Belitung University. Yes, please keep polite attitude with positive spirit. You can read here in Indonesia. Yeah, Yes, this is very important. Yes, please keep polite. Especially Indonesian people is very polite. Yes, it is our honor that Indonesian people is very polite. Yeah, and always take care dream. Yes, I think everybody have the dream from the future. Yes, including me. I have the dream to build the synthetic aperture radar on the radar for my father. Yeah, it is when I'm 5 years old in 1975. Yes, I said to my father, and I want to realize for my father. And I realized when I'm in the old of 48, yes, 47, yes, 47. So it means I need about 42 years, yes, long, yes, to realize the dream, what I said to my father. Even it's very long, but it is no problem. Please keep your dream. Yes, it is very important. Yeah, and then always recognize your word. Yes, so it is your word is very important. You must know about yourself. Yes, what is the weakness and what is your strength. Yes, it is very important. Yeah, in my case is yes, I think I'm strong in microwave and also in electromagnetic. So why I work in in this field. Yeah, and then yes, I hope after this semester, yes, I will write summarize my books in Indonesian. Yes, about this electromagnetics. Yes, and I hope you can find it's very easy to read the electromagnetics. Yes, and I hope some of you can follow and continue my work. Yes, and then you can establish your own, yes, your original thing, yes, that it is born from Indonesia. Okay, and then always talk and think positive thing. Please consider just positive thing. If not the people said the negative thing, please make the natural. Yes, sometimes yeah, I heard some people is talk about another people and the negative one. It is not good. Yeah, please just consider positive thing and make another people happy. And please if something someone is fine or invention something, so please support to him. Yeah, and sometimes is some people is failed. Yes, so please also help them. Yes, it is very important. Yeah, especially for your friend right now, please make many friends. It is very important for your future career. Yeah. Okay, stand up soon from failed and lose. Yes, it is very important. If you lose today, please tomorrow is wake up and to be happy. Please forget. Yes, and then recover what you made the failed and lose. Yeah, and then always see and consider good side of other. Yes, your friend, please consider just good thing. Yeah, please don't consider just the bad thing. It is very important. Because our brain is the memory is not so many, so please just keep or save the good thing in your memory, in your brain. Yeah, okay, and then collecting the strength and advantage. Yes, it is very important to collect the strengths and also the advantage. Yeah. Okay, and gaining confidence. Yes, self-confidence, it is very important. Yes, please, always confident or semangat. Yes, every day. Yeah, like in my house, yes, my son always say to me that I'm always smile and always loud. It is very important. Yes, to keep our family, our friend, all is happy. It is also very important. Yeah. Okay, optimistic and forward looking for the future. Yes, just optimist. Yes, optimism for your future. Yes, and keep confidence, and then strength. Yes, build the strengthness of your life. Yeah, and it is also very important. Your laboratory, your university, and your work. Your college. It is friend is your treasure. Yes, it is our treasure. Yeah, because I like to discussion. Yes, if I have some problem, I discuss even with my student. I'm always discuss with my student. Yeah, because sometimes my student is know very well compare me. Yeah, so in this case, I learn from my student, and of course, I also teach to them. Yeah, and then I collect all of a good thing in my head. Yes, so in this case, I can, improve myself. Yeah. Okay, and then finally, in the sharing knowledge to the world, it is in the final one. Yes, if you have the invention, first is patents. Patent is very important, and then submit it for the peer-reviewed journal. Yes, after that, present to the conference. Yes, and then you can contribute from the world. Yes, it is, please guard your right first. Haki, yes, in Indonesia haki, hak kita ya, kekayaan ilmiah kita ya, hak atas kekayaan ilmiah kita is very important. Yes, please keep your haki and then contribute from the world, yes, and the people, because I hope more Indonesian people can contribute from the world. If you contribute from the world, I think many people will help you and to be your friend, and the country to be in the more, more bigger. Yeah, like now Indonesia is very big, and we need more thinking, a good thing, positive thing to build Indonesia. And Indonesia is good from the world. It is our dream. Yeah. Okay. It is my last talk, and thank you very much to all of you. I hope you can learn what from my talk, and you can do your with your original, yeah, and your only one thing, yeah. And okay, if you want to know about our activity in my lab website is very simple. Yes, I made very simple because this is from the security of our laboratory. Yes, and you can read this here. Yeah. Okay, thank you very much. And I give back to Dr. Priyoko. Yes, I hope we can open the question and answer. Yeah, thank you. Yeah. Still mute? Yeah. Pak Priyoko, may I have 2 minutes? Take a rest.
I cannot hear Prof. Priyoko voice.
Mr. Priyoko, unmute the mic, please.
King, yeah. Perhaps in the Zoom room cannot hear my voice, but how about now?
Clean and
It's
clear.
fine now.
All right, thank you very much. Because in this room we have a very clear sound. All right, I just mentioned about what Professor Yo has already explained about the microwave remote sensing technology that he first consider about Indonesia is very big countries, yeah. So the question is from Prof. Yo is actually what you can do with this situation. Indonesia is very big, and what you can do with this situation. And then next, Prof. Yo wants us to take the opportunity to collaborate with him, with his laboratory. If you want to continue your study in Japan, you just contact to Prof. Yo anytime, yeah. And also he mentioned about GMRSL, Yosafat Micro Remote Sensing Laboratory. What are their activities? And then he also mentioned about several kinds of research results from radar, micro antenna, yeah, and also this kind of radar can applicate with the disaster monitoring, for example. And Prof. Yo also mentioned about the application of the remote sensing technology or microwave remote sensing technology, for example, for application in disaster monitoring, natural resources, research and rescue, and then home security and terrorist or anti-terrorist mission, and lastly, infrastructure monitoring, like mapping the areas and also maintenance the facilities and so on and so forth. And also the words that's very important, what Prof. Yo told to us, that originality is very important to us, to invention something, to invent something, yeah. Prof. Yo also explains several examples of his research, for example, in mapping and image processing. Take cases in Lapindo and coastal of Jakarta, in Merapi, and subsidence of Bandung. Also some examples in Japan, Malaysia, yeah, and also some information, good information from marine science that has already been example in Indonesia and Japan. And lastly, he mentioned is a very good wise word for students that wants to be successful in the future. Among them is polite, and you have keep your dreams and recognize our worth, and so many wise words that we can hear just now. And now I'm sure that you have many questions to Prof. Yo. I mentioned from the chat room at least 6 questions from chat room. But we have also audience in this room. And then I would like to divide by 2 sessions. First session in this room and second session in the chat room. But I would like to mix it up. Yeah, 2 questions from this room and then 2 questions from chat room. So the first session, I would like to give the opportunity to the audience in this room. If you would like to ask directly to Prof. Yo, I will give 2 questions first. Any question from the audience in this room? 2 questions, please. Okay, I got it. 2 of them at the back side, yeah. The committee, could you help give the mic to the audience? The girl one and the boy one. Just tell your name and your institution, perhaps of marine science or something like that, and then your question. Yeah, Prof. Yo will hear you directly and can also answer directly to you. Okay, for the first question, please.
Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good morning, everyone. I'm Robbie from Marine Science, Bangka Belitung University. I want to ask. I have read an article where the article describes Society 5.0, which was initiated by the Japan Federation in 2019. The era focuses more on the human component. What I want to ask is if the Society 5.0 will have impact on development of microwave remote sensing in Indonesia and the world itself. Thank you.
Are you clear, Prof. Yo? The question?
Okay, yes, maybe I can directly answer. Yeah,
please.
Okay, yeah. Okay, but the Society 5.0, yes, this is I think this society to realize this society is need many technology. Yes, this one of the technology is how to get the precise, for example, the precise information of the land surface. Yes, because the land surface is not just the disaster. Yes, we also need the support to find the good food. Yeah, for example, yesterday is the World Foods Day. Yeah, so in this case, is we need to focus good foods. Yeah, the good foods is the precise agriculture. Yeah, the precise agriculture is need high resolution and also more information. Yes, about the agriculture and also the time series. Yeah, a good time series of the information is also very important to get the near real-time society. Yeah, because near real-time society, the movement of the society, and also the food. Yeah, the real information of the food is very important to predict what happened in the 1 week later or 1 month later. Yes, in the world. For example, right now, yeah, this is like in Japan, is maybe no problem. Yes, because we keep the agriculture here, and also we got the the food from the Vietnam and Thailand, and of course from Indonesia. Right now, it's from fruit. Yeah, fruits is from Indonesia, Vietnam, and but what happened in Africa? Yeah, why in the Africa is is still a big problem. Yes, in the food. Yeah. And to keep this one is I think it's many effort. Yes, in my case, yes, in how we can contribute for the society 5.0. Yeah, so in this case is we develop the high resolution synthetic aperture radar. Yes, with the resolution right now is 35 centimeter. Yeah, even many sensor is still 1 meter or some 50 centimeter, but our sensor is 35 centimeter. Of course, we can make more smaller. 5 centimeter is of course we can do. Yeah, and then time series. Yeah, right now we also developed the sensor for the stratosphere platform. Yes, hubs we call it the hubs. Yeah, hubs is a high altitude platform system. Yes, using the drone, and then we put our sensor. We can fly for the one fly. Is we can continue for 6 months. Yes, 6 months. Flying. Yes, so in this case, and we can get the information of the land. Yes, it is almost 24 hours. Yes, because if we use the synthetic aperture radar spaceborne one, yes, the satellite, it is to get the information of one place in the same place. It is we need at least is 1 month. Yeah, every 1 month is we can get the data, but between the 1 month is we cannot. In this case, it's big problem. Yeah, so in this case, is the time series is also important. Yeah, so of course we can do for the application. Yes, like I already mentioned. Yeah, a good society. Yes, and the future in the IT. Yes, the IT society. Yes, it is also IT is mean need a good data. It's not just the hardware. Yes, the good data. How to find the good data if the sensor is not good? Yes, so in this case, is I deliver the good and the best sensor in the world. Even right now, yes, the best sensor is my sensor. Yeah, but now I'm improved and to be continuously to be in the best. I don't know. In the future, maybe another people will invent it more best. Yeah, more better than our sensor. But at least it's right now is our sensor is the best. Yeah, I hope we can also support the society 5.0 using our invention and our sensor. Yeah. Okay. It is maybe you can answer the question. Yeah.
Okay, thank you. I think it's clear. Yeah.
Yeah.
The answer is about real time, time series, and also good data.
Yeah.
All right. The second question, please.
Okay, thank you. Good morning. Excuse me, Prof. and everyone. My name is Veronica, one of the 5 semester Marine Science University of Bangka Belitung. Before that, I would say thanks to my major, my lecturer, and University of Bangka Belitung for facilitating us in this international seminar. And my question, why is professor motivated to develop microwave remote sensing? What is the greatest motivation of professor that might later motivate us as well as agent of change in Indonesia, especially in Bangka Belitung Island? And how did you introduce microwave remote sensing in Indonesia in the first place? Because we know that remote sensing is very useful for the future, especially in the marine science example, make a map for research and others. Yes, thank you.
Okay, Prof, you can directly answer the question.
Okay, thank you very much. Yes, especially for Indonesia. Yes, of course, I love Indonesia very much because my parent is still in Indonesia. My brother, sister also in Indonesia. Yeah. Okay. Of course, I'm, one of my motivation to do the work in remote sensing, especially in the synthetic aperture radar. Like I mentioned, the most motivation is because it is my dream that I want to realize the radar for my father. Yeah, for my father, for the TNI AU. Yes, it is my because sorry. Okay. Maybe some repeated. Yeah. Okay, yes, because to realize something, yes, it is for example for Indonesia, yeah, Indonesia is for the TNI, yes, I think the technology is not so much, yeah, and how about the Kemandirian Nasional, yes, about the technology, yes, so in this case, we must do by ourselves, yeah, so you cannot buy the technology, transfer technology from the overseas, it is nonsense. No another country can help you. Yes, you must do by yourself. Yes, and many people we can do the transfer technology. I think you can get the transfer technology, but the technology itself, maybe the technology of the 20 years ago or 30 years ago. Yes, it is already old. Yes, old technology, or we call it the usang. Yes, if you use the usang technology, is you can guard your country, yeah, you can save your country, it is nonsense, yeah. I think it's you must do by yourself. So why please don't use the budget to buy something from the overseas, plus please do for your to strengthen the research and the technology in the university and the research center, yes, in the Indonesia, because if you can do something, for example, the corona, yeah, the vaccine itself is in Indonesia is maybe some of the people is created the vaccine. So why we don't support them? Yes, we must support them. Yes, it is very important. Yeah, and then like another country, yes, they will do and by their invention. For example, the Russia with the Sputnik, yeah, and then the Sinovac of the China. It is even many controversial, but it is very good. The invention, yes, and then from the radar. Okay, back to the radar. It is also why I do and all of the Indonesia. Of course, many people ask me why I'm, in Japan, and I didn't contribute for Indonesia. It is a big mistake. Yeah, I'm, the professor in Universitas 11 Maret. Yeah, and I'm also, I send every year about 2,000 Japanese students to Indonesia. Yeah, and I also pay, more than 1,000 Indonesian students to come to Japan. Yes, using my budget. Yes, it is to learn in Japan and find a good positive thing from Japan, and then please employ in Indonesia. But employ is not 100% copy. Yes, just the technique. Yes, and then the idea is from yourself. It is what I'm always teach to my student. Yeah. Please do the original, the only one. in the thesis of my student, I'm always first, what I ask to them is, what is the original one? Yeah, because it is the, I don't want my student copy, another research, because if they copy from another research, it's waste time and also waste money. Yes, because I don't want to do the same thing with, that already did by another people. Yeah, okay, and I also bring many international symposium, like next 2 weeks ago, 2 weeks later, in Bali. Yes, it is Asia Pacific conference on synthetic aperture radar. It is the big international symposium IEEE, and I'm also the general chair. And why I do in Indonesia, in Bali? Yeah, it's not in Japan. Yes, it is, because I love Indonesia, and I hope many Indonesian people will, interact and communicate with the expert of the synthetic aperture radar in the world. Yes, and then you can learn. Yeah, and yes, I invited many great people. Yes, from the Germany DLR, and also from the NASA, and from Japan JAXA. Yes, and also from Korean KAIS, yeah, and also from the Europe, yeah, and the Europe is the DLR, and also from the Italy, yeah, and it is I bring to Indonesia because if you go to overseas, yeah, you spend much money, yeah, so why I don't invite them to Indonesia? Yeah, so I invite them, yes, and then they come, and you can interact. They can interact with many Indonesian people. It's not just 1, 2, yes, but 100 or maybe 1,000 people. Yeah, it is very very important. Yeah, okay, and I hope Mbak Veronica and also another student can help me, yes, to do something new for Indonesia. Yeah, new Indonesia. It is our our dream. Yes, to be Indonesia, strong Indonesia, new Indonesia, and health. Yeah, health Indonesia. It is our dream. Yes. Okay. Let's build Indonesia together. Yeah. Okay. Thank you very much.
Thank you. What a fantastic answer from Profio. I think Veronica is clear. Yeah. All right. Now, next, I would like to read the question from Zoom room. The first question is from Dr. Umi from FPIK UB. I think UB is University of Brawijaya. Yeah? The question is, how deep is the power of microwave remote sensing of ground radar can penetrate the soil? With the types and composition of soil influence this power? Thank you, Prof.
Okay, thank you very much for the good question. Yeah, about the synthetic aperture radar, if you want to penetrate, yes, it means better you use the long wave or long wavelength. So it means it's low frequency. Unfortunately, right now is we can use just P band and L band. Yes, when the center frequency is 0.8 or 0.6 gigahertz and 1.275 gigahertz. So in this case is what the soil condition, it is the dry, the dry soil. Yes, like the desert area. Yes, at the Taklamakan or at the Arabian, peninsula. Yes. Okay, yes, I went many times, yes, to Jordan and another country, and also the and the Sahara. Yes, it is dry. In this the case of the dry object, so it is we can penetrate small. Yes, because the dielectric constant is very low. Yes, close to the 1. Yes, so in this case is we can penetrate more using the low frequency of the synthetic aperture radar. But unfortunately, if we want to observe Indonesia, Indonesia is almost all of the area is wet soil. Yeah, from the wet soil, is the dielectric constant is higher compared to the dry. So in this case, is of course, we can use the long wave L or P band, say, to can penetrate. But we can penetrate some meter, yes, maybe just 2 meter, yes, or less than 5 meter, if we want to observe the Indonesian area. I have the experience to observe the peatland area in the central of the Borneo or Kalimantan. Yeah, so in this case, we can penetrate just a couple of the meter, yes, because this is the wet soil. Yes, when the dielectric constant is about 5, yes, 3 or 5. Yeah, yeah. So in this case, the point is the long wave or low frequency and dry soil. Yeah, if you want to observe, for example, the Timor Island, yes, on the Nusa Tenggara Island, yes, it is a good, yeah, you can penetrate. Or in the southern part of the Java, like the dry area, it is from the Banyuwangi, yes, Banyuwangi, and then Pacitan and Gunung Kidul, yes, and then I'm forget, and the Kebumen, yes, Kebumen area is also can penetrate maybe more than 2 meter, yeah, if you use the L band or the P band, yeah. Okay, maybe you can answer the question. Yeah.
Thank you, Prof.
Oh, yeah, you're welcome. Yeah.
Yeah, I think we have additional question from you, Dr. Umi.
Yeah.
The question is, what is the difference between CP and other radar mechanism?
Okay.
Will the data produce different?
Yeah. Okay. Yes. First is the name is different. It means the characteristic is different. Yeah. The linear polarization is the horizontal polarization and vertical polarization. But in my case, it's circular polarization. Basically, if we use the linear polarization, horizontal and vertical, it means the information of the horizontal and vertical. Of course, you can convert from the linear polarization to circular polarization, but some effect, including the ionospheric effect and also the in the cloud, yes, especially if you want to use the high frequency or a short wavelength, it is affected by the cloud, yeah, on the water drop, yes, inside the cloud. So in this case, if you want to avoid this effect, yes, the Faraday rotation in the ionosphere and also the some of the we call in the water evaporation effect. So in this case, I recommend using the circularly polarized synthetic aperture radar, because the circular polarized, the object, yes, if the object itself is even the what in the situation, yes, it is a change. If you use the circular polarization, you can get the scattering of the the condition of the the object. If you use the linear polarization just on the horizontal and vertical, you can, maybe you cannot reconstruct the object. Yeah. So why the CP is I think is the future technology of the synthetic aperture radar. Yeah. Okay. Yeah.
All right. Thank you very much. I hope Dr. Umi is satisfied with the answer.
Yeah. Yes, I work with the Pak Fauzan, yes, and Teknik Elektro UB, yeah,
I see.
Yeah. Yeah. Before I also teach in UB, yes, and I have
really
course at Gria Santa, yeah, yeah.
Oh, I see.
Yeah.
Yeah.
Okay. Yeah.
I wish I could we could meet in personal, Prof.
Oh, yeah. Thank you very much. Yeah.
Thank you very much.
Yeah. Dr. Prof. Dioko, would you mind if I just mention just last question for Prof. Jo? Is that all right?
That's okay. Go ahead.
Okay, Prof. Jo. I work in the Faculty of Marine Fisheries and Marine Science as well in Brawijaya University. So the application of this technology in marine science will be very, very important for us to know. So, and you already mentioned the product and also the research in the marine science a few minutes ago. But my question is, since the microwave technology can penetrate until a few meters, even in land or water, can it takes prediction for the futures, the data? I mean, it's like what you said in what is that, the north of Jakarta, they will become land by themselves actually. In many years. So this product can predict actually what happened in the futures. How long it takes, I mean, the prediction. Will the prediction applied or something like that? Thank you.
Okay, yeah. Thank you very much for the nice question. Yeah, upon the prediction is we need the input of a long-term observation. Yes, before. Yeah. For example, I observed the Jakarta, Bandung, you know, the Bandung Basin. Yes, from the Pangalengan. Yeah, and then through the Citarum. Yes, River Citarum, and then the watershed of this area, yes, including the close to the Cengkareng, yes, and the Tangerang, yes. I you know made a very long term and a very hard, you know, a large area, yeah, and actually, I also like to do the ground survey. So I'm always go to somewhere, and I'm also exciting to go to the Bangka Belitung. Yes, actually, yeah, to do the, you know, the ground survey.
It's a nice place in Bangka Belitung. There was a nice beach.
I heard much. Yes, I hope I can visit. Yes, the Bangka Belitung. Yeah, and of course the East Java. For example, the Lapindo. Yeah, Lapindo itself is I made the observation since 2006 until right now. Yeah, every year I collected many data and I collected many information, and almost every 1 year or every 2 years I visit. You know, visited the Lapindo to collect some sample, yes, including the water itself and many, yeah. And then I make the analysis, and then I make the summary, yeah, including the Jakarta, yeah. The Jakarta itself, I also have the hobby, yeah, the hobby to collect the geometric corrected of the old map, yes, old map that made by the what is Netherlands? Yes, it means I have the original one. Even the Indonesian government don't have the original, you know, old map. Yes, I also have all. Yeah, and then based on many information, the old map and also my ground survey and also the radar, you know, analysis, and then I made some summaries that some place of the Jakarta, yes, it is some place is abrasion. Abrasion is mean the coastal line is reduced, and some part is to be increased. Yes, increased because of the sedimentation from the, you know, estuary, yes, some river, yeah, river from the Citarum and also from you know, Tangerang, yeah, have the Tangerang city, yes, it is some area is abrasion, but some area is, you know, you know, increasing, yes, increasing the coastal line, yeah. So why the shape, why of the shape of the Jakarta stride, yes, like this one, yes, it is have some reason, yeah, I know the reason, yeah, yeah. So okay, yes, I think it's like I mentioned in my last advice to the student, yes, please have the curiosity, yes, too many things, yeah. Even my job is in the synthetic aperture radar and the electromagnetic, but I have some you know, curiosity, yeah. I learn many, yes, but the language I also learn, yes. Right now I learn about the Javanese, yeah, how to write the Javanese, yes, and I send my a Japanese student to Universitas 11 Maret to learn about the Javanese, yeah, to read the Javanese. Why? I need to learn about the Javanese because Indonesian is just born is in 19 after the 1945, yeah, and before it we use the Javanese, and many record of the environment written in Javanese. So in this case, I learned the Javanese too, yeah, and I collected many Javanese, and I also translated many documents in Javanese. Yeah.
Wow.
Yeah. So
thank you so very much.
Yeah.
Prof. Joe. Thank you,
okay.
Prof. Prioko.
Okay, you're welcome. Yeah, thank you.
Thank you, Dr. Rumi and Prof. Yo. And the second question from Zoom room is from Nugraha. Nugraha is from Universitas Bina Niaga. Yeah. The question is, as we already know that INSAR obtained line of sight or LOS result, how convert LOS to get vertical displacement?
Okay, yeah. Maybe I can, in my paper, yes, in TGRS, actually talk about this, how to convert. Yes, it is very easy. Yes, just divide by the cosine and the incident angle. Yes, but from the detail is in the, what is, sorry, maybe I can show.
I think this is a correlate with the second question.
Yeah, okay, yeah.
Could you show us where is the address to download GERS data? GERS.
GERS. Oh, you mean SAR? SAR?
G.
G
You
E
download the GERS data.
ERS. Oh, GERS1. GERS1 data. Yeah.
Yeah. Yes.
Oh, okay. Okay. Yeah. You can get from the G hyphen porta. Yeah. G porta, not free of charge. Yeah. It is, but unfortunately, GERS1 data is collected from 1992 until 1998. Yeah. And then for the other data is, for example, ELOS. Yeah. Maybe ELOS will be open soon. Yes, free of charge. Yeah. But for the ELOS2 is you must pay. Yes. Still, what is, it's not free. Yeah. But another one is you can use some European SAR data. It is from the EO, I think EO portal. Yes, it in the ESA atau or the Earth Observation Portal. Yes, on the you can with the small character EO portal. Yes, it is you can get the data of the ERS1, ERS2, and Sentinel. Yes, some Sentinel data, Sentinel A1, A2, and sorry, 1A and 1B, and also the NVSAT. Yes, it is also free of charge. Yes, please don't worry. Yes, now is era of the open source. It is you can. So in this case, is just the idea. The idea is not open source. Yes, it is you must you know develop by yourself. Yeah. Okay. Maybe I can show. I think it's one of the slide. Yeah. You can see. Yeah.
Yes, clearly.
Yeah. Okay. Yes. It is you know from the we call it the master. Yes. Master and the slave. Yes. It is very long. Yes. It is more than 700 kilometer. If more than 700 kilometer, because the height is 560 kilometer, and it in the slant range is more than 700 kilometer. It means you can see it is almost parallel. Yes. So if the object is moved, yes, move like this one. Yeah. So in this case, is you can extract the DZ. Yes. This DZ is you can extract using the change of and the loss. Yes. Line of sight. Yes. A line of sight is here. Yes. This two line of sight is you can get the change of the phase. Yeah. From this, the change of the phase is you can extract the DZ. It is the vertical change. Yes. Sorry. Maybe. Okay, you can see.
Yeah.
Yeah, this one. Okay. You know, this is the line of sight. Yeah, because it is very far. Yes, 700 kilometer, and it is almost parallel. Yes, to get, for example, the here is the change of the vertical change, DZ. Yeah, this DZ is you can extract using the change of the DR. Yeah, this DR is the range. Yes, or slant range change. Yeah, the slant range change is you can extract the information is from the line of sight. Yes, and this is very easy. Just it is in the incident angle. This DZ is equal to the DR divided by the cosine of this this incident angle on the theta I, theta the incident. Yeah, for the detail, it says in my paper is include. It's not just the DR. Yeah, DR itself is we can extract using the the baseline, yeah, the change on the height of the baseline and also on the baseline itself on the B and also on the horizontal baseline. Yes, it is in detail. Yeah, and in my new paper, yes, will be published in IEEE TGRS. It is another one when I observe by using the new method for the Lapindo area. It is I use a close a similar technique, yeah, to extract this one, yeah, the vertical change. Yeah, from the horizontal change is also same. Yes, you can just divide by the sign of the incident angle. Yeah, okay, it is maybe can answer the technical question. Yeah.
Yeah, okay. I think Nugraha interested to have a scholarship from you. That's why
Okay, yeah,
the third
yeah.
question is, does GMRSL provide scholarships for students who want to study at Chiba?
Okay, my student actually got is not from my laboratory. My laboratory give the technology. Yes, it's not the scholarship. Yeah, from the scholarship is from Indonesia. Is many student is come from using the LPDP. Yeah, and also from before is from the Lapan. Yes, Lapan is sent 10 students, yes, to get the PhD from my laboratory. Yeah, and also from Universitas Islam Riau, yes, Pak Husnul is got using the LPDP. Yeah, and the other one is from Mombusho. You can get the website of the the Kedutaan Besar Jepang at Jakarta or Konjen. Yes, I think you can find the information of the scholarship. Yes, of course, if you get, for example, you are the private student and you get the, pass the entrance test in Chiba University, you can register for the scholarship from Chiba University. Yes, Chiba University deliver some scholarship for the excellent student. Yes, excellent student. It means you must show excellent, achievement before. Yes, that to find or to get the scholarship later. Yeah. Okay. Don't worry if you are excellent. Yeah.
All right, thank you.
Yeah.
I hope Nugraha you're clear already. Yeah.
Yeah.
So now we go back to this room. We have two audiences who would like to ask. Yeah, just raise your hand. Okay, there are two people, two young people here in the front. Please, do you have a mic already in your hand? Okay, just stand up and please say your name and your institution and ask directly to Profio.
Good morning. Introduce myself. My name is Asfari Maindra. I am third semester of Universitas Bangka Belitung of Marine Science, and I like to ask to Professor how much time for your device, your SAR UAV and airborne UAV to process the data. From comparing the after the disaster and before the disaster, like for example, like there's earthquakes, you compare before and then the after, and then you predict what happened next, like what will happen if there's another earthquake like that. Thank you.
Is it clear for you, Prof. Yo?
Sorry, in the beginning is I didn't got the question because the voice is not clear. Yeah.
Yeah, can you
Could you repeat? Yeah.
repeat again with a simple ask question?
How much time for the SAR UAV and the airborne SAR to process the data, and then after it, like collect the data from the UAV and the other things?
Okay. Yes. For the processing, it is less than 60 seconds. Yes. It is less than 1 minute. Yes. For the data every frame. Yes. Every frame, because right now is the computer is very fast. Yes. So in this case is less than 1 minute. Yes. It is even UAV and the aircraft is almost same. Yeah, because we put the server, yes, server, a very high speed server in the our system. Yeah, and then to predict the earthquake itself, yes, it is we use another technique. Yes, of course, the synthetic aperture radar is we use to know the impacted area by the disaster itself. Yes, but before the disaster is we use another technique we call in the GPS RO, yes, or radio occultation. We can predict the earthquake before the earthquake is. We can predict 3 days or 5 days before the earthquake. Yes, so in this case, even it's not officially announced. Yes, but I hope in the future after we improve this technique is we can make the system for the prediction of the earthquake. Yes, before the earthquake 3 days or 5 days. So in this case, is we have much time. Yes, to move and to save our property. Yes, before the earthquake come. Yeah. Okay, maybe can answer. Yeah.
It's clear, yeah?
Yeah.
All right. So the next guy, say your name and your institution.
Okay, good morning. Thank you for the opportunity. Let me introduce myself. My name is Dimas from Marine Science Department. And my question is, we know there is many kind of satellites that are used for certain purpose like MODIS, Landsat, Aster, and Dubai satellite. And from the journal I read, there were several satellites asked to file in their operation. My question is, how do we know the accuracy of the satellite based on anything to be made as a satellite that has high accuracy, like thermal, radar, and microwave? Thank you.
You means about the system?
Yes.
The system, how to make the accurate? Yes. Okay, I think it's many technique to improve the accuracy of the satellite. At least first in the GPS. Yes. In the satellite is we put at least is three receiver of the GPS to know about the information of the we call as the attitude. Yeah, attitude condition of the satellite. Yeah, this one is we need to derive the position of the satellite, and then the yawing, rolling, and pitching. Yes, pitching. Yes, it is in the angle of the satellite itself. Actually, the orbit of the satellite is not completely straight. Yes, but it is look like the snake. Yeah, the snake face. So in this case, is we need to correct. Yes, to correct it means we need the accurate of the position of the satellite itself. Yes. For example, the JERS one, yes, on the ELOS, it is they made every month is the time. Yeah, the time of the record is to correct every 2 seconds. Yes, 2 seconds. Adjust it 2 seconds. Every month is 2 seconds. Reduce. Yeah, because the change of the track of the satellite itself. So Our satellite also same. Yes, we put the IMU. Yes, from the inertial what is measuring the unit IMU to collect the information of the angle. Yes, it is in the rolling, pitching, and yawing, and also the position of the satellite. It's not just the GPS. We also using the coarse sun sensor or CSS. Yeah, CSS is to know the position of the sun. Yeah, if we know the position of the sun, we can predict where is our position. Yeah, of course the GPS is we have the information of the GPS, but it's not enough. So in this case, it's using the CSS. Yes, and CSS we put several sensor of the CSS, and the other one is we also use the like the magneto sensor, yeah, to know the magnetic what is density of the when our satellite is moved, because the magnetic density in our Earth, yes, our planet, is almost different. So if we know the flux of the magnetic, we can predict. Oh, we are where. Yes, it is depend on the flux of the magnetic itself. So I think it's many sensor we can use to improve and the position of the satellite. And okay, next is have what is a relation with your question. It is if we know high precision of our position. So in this case is in our case is synthetic aperture radar. We will know about the pitching angle. Yes, on the beam of our radar. Yeah, if we know the beam of our radar precisely, I think is you can get the image. Yeah, image of the radar is very precise. Yeah, if you can get the image is very precise, and you can the position of every pixel. Yes, every pixel of the image is also precise. Yeah, but our target is less than 1 pixel. Yes, less than 1 pixel. You know, 1 pixel is the resolution is 10 meter. Yes, if 10 meter error, it is still okay for us. Yes. Okay, maybe you can answer. Yes, to Mas Dimas. Yeah.
Okay, thank you, sir.
Okay, you're welcome.
Okay. All right. So then we go to the Zoom room question. There's a question from Henky, but we don't know from where. Henky and UBB. All right. The question is in Bahasa Indonesia, yeah. So he mentioned that please translate it first to English. All right. Is there any possibilities to put radar into drone, which is commercially, sell, and can use the application which compatible with the Android or iOS?
Okay. Yeah. Okay, may I answer?
Yes, please.
Okay, yeah. Okay, the drone of the synthetic aperture radar actually maybe it's very hard to buy. Yeah, because it is have the security issue. Yeah, maybe in United States is maybe more strict. Yes, privately I think you can get, but our laboratory we have because we develop by ourselves. Yes, the UAV and also the synthetic aperture radar, and we have a multi-band. Yes, with several band. Yes, with the several frequency. In this case, is the object and the data itself. It is different. Yes, different is means different of the scattering and the good to classify. Yeah, right now is and the deep learning. Yes, deep learning, machine learning, neural network is also one of the trend trend field right now. So some of my student is also combined. Yes, this deep learning, machine learning with the synthetic aperture radar to get more precise information, more precise position. Yes, using this technique. Yeah. Okay. And then yes, about the what in the last one. Yes, it is
the compatible of
yeah
with the iOS or Android.
Oh, okay, Android, yeah. Okay, yes, of course, yes. From the Android itself, one of the technique, hardware itself is we can employ the Android itself. Yeah, like now I develop yes in the in this my side. Yes, it is using one of the application of the Android itself. Right now it's very small. Yeah, and the weight itself is before is when we put in the CN235 and Boeing 737, the weight is 80 kilogram. Yes, but right now it's less than 5 kilogram. Yes, using the Android, and yes, we can combine with the IoT. Yes, technology, and in the future is maybe the radar and the UAV can move by themselves and then get the data that we need. Yes, real time. Yeah, it is just our dream. Yes, maybe less than 5 years we can realize. Yeah.
All right, thank you very much. And the second question from Eka Sofiatun. I am marine science student of UBB. I have something to ask. What do you think if we should do to be able to learn and master remote sensing technology and application while we don't have the equipment needed for training?
Okay. Yes. It is. Don't worry. You can use. Some of the software. Many open software. Yes. Like you can use the SNAP. Yes. SNAP. Yes. Of the ESA. Yeah. European Space Agency. Yeah. SNAP. You can just put ESA. Yeah. In bahasa is ESA. Then space SNAP. Yes. SNAP, yes, and then you can get the software itself, and the data itself also free of charge, yes, including the from the EO portal of the ESA, yes, you can get like the ERS1, ERS2, and also the Sentinel. Sentinel 1A, 1B, and also the NVSAT. Yeah, Sentinel is right now is still operated. Yeah, and also from Japan, you can get the data of the JERS1, and I hope in the future the ELOS is also to be the free, and ELOS2 is I hope also the free after the ELOS 4 is launched. Yes, I think it's it is possible. You can start right now. Yes, after my talk finishes, you can try. Yes, access and download. Yeah, and then try. Yeah, and the manual itself is many, and you can get in the YouTube. Yes, and also the website of the ESA itself. Yes, please don't worry. Yes, you can start. Yeah, you don't need the basic knowledge of the electromagnetic. Yeah.
All right, you can play it right now.
Yeah, yeah.
Okay, we have still 2 questions from Zoom room, but before I read out the question, I need one more question from this room. Is there any audience wants to ask one more question?
Yeah,
that's the only one. Yeah, I'm sorry, we have only one opportunity. Okay, do you have a mic on your hand? Mic? So we still have 3 questions, Profio.
Okay, no problem. Yeah.
All right, just say your name and your institution and your question, please.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
I am Fatima Azahra from Marine Science University of Bangka Belitung. I have a question. My question is whether there are certain factors that can affect the accuracy of the data obtained from the satellite. Thank you.
What kind of the factor? Can you repeat again?
Anything, Pak, Mister.
A factor. Okay, yeah. Okay, the factor that affected to the data of the synthetic aperture radar, yes, especially synthetic aperture radar, it is uh, first is the Faraday rotation. Yeah, it is the flux on the concentration of the electrons in the ionosphere. It is a big problem for us. Yeah, especially from the long wavelength. Yes, on the low frequency will affected to the phase. Yeah, the phase information. If the phase information change, it means line of sight. Yes, information it is will change. In my equation is dr will change. Yeah, if dr change, it means the dz and also the x. Yes, the vertical and horizontal change also change. Yeah, so it is a big problem. So, and the other one is also the evaporation. Yeah, the evaporation is like the cloud. Yeah, the cloud is if we use the high frequency. Yeah, X band and Ku band, K or Ka band, Ka band. Yeah. So in this case is because the wavelength is very short, so the object is big. Yeah. So in this case, in the scattering, yes, it is to be stronger. Yeah, and some frequency will be absorbed. Yes, and multi-scattering. Yes, inside the like the water droplet. Yeah, it is a big problem for us. So in this case is we call as the atmospheric effect. So how to remove the atmospheric effect? It is also one of the technique. Yes, because the distribution of the, for example, the cloud itself, this is very long. So in this case is if you use the high frequency, and you can remove the low frequency itself, because the low frequency is the effect of the atmospheric effect itself. So we have some technique. Yes, like the atmospheric phase filtering. Yes, phase filtering technique to remove this effect of the atmospheric itself. Yeah, and I think it's many. Yes, including the hardware itself. Yeah, the hardware, how to keep the temperature. Yeah, the temperature is a constant. Yes, it is also a big problem, because when in the in the space, when facing to the sun, it is the system, the antenna itself is the surface temperature is more than 100 degree. It is more than 100. And when the satellite is on the back of the Earth, so in this case, in the nighttime is the system itself is to be minus 50 degree of Celsius. Yeah. So it is 100 to minus 50. It is changed drastically in short time. So in this case, the system is the noise. Maybe you remember, yes, when you learn in the high school in the basic of the physics on the mathematics, yeah, that the temperature is almost equal to the noise. Yes, and the noise, it is NKTB. Yes, the T is the temperature in Kelvin, and the N is the the noise itself. If the T is high, it means the noise is also high. So how to keep? Yeah. So why our sensor? Yes, if possible, in the antenna we put the refrigerator and also the heater. Yeah. If in the facing to the sun, it is very high temperature. So we will turn on the refrigerator to down the temperature itself. And in the nighttime, so it is minus 50. So in this, the antenna is need the warm. Yes, it means we need to what is using the heater. Yeah, to heating the our antenna. Or our system also same. Yeah. So I think it's many problems. Yeah. We must solve one by one, and the problem itself is our invention. we find the problem and we solve using the new technique and the new method, and to be, it is our invention too. Yes. No problem. Many problem is a good thing. Yeah. Okay. Yes.
All right. Okay. Thank you very much. Fatima, are you clear? The question, the answers? All right. Okay, good. Now we have still two questions from Zoom room. First from Ririn Amelia from UBB. Good morning, sir. When we compare to the other methods, what are the advantages and disadvantages of using the DINSAR method in monitoring the deformation of an area? In your opinion, what are the opportunities for remote sensing in overcoming spatial data problems? Thank you very much.
Okay, the DINSAR itself, yes. If we compare using the optic sensor, yeah. If you use the optic sensor, yes. For example, yes, lens subsidence of. Okay, maybe I can answer. Yes. For example, if we use the synthetic aperture radar, we want to observe the lens subsidence. Yes. At right now, I continue to observe the Semarang. Yeah. In the Semarang city is, yes, I think is many problem. Yes. So in this case is the DINSAR. If we use the optic sensor, yes, it is impossible. Yeah, because the optic sensor is, for example, one time we got the data. For example, in 1992 of the data, and then you observe in 1993. Yeah, and then you compare the data of the optic. So you cannot get the accuracy of the less than 1 meter. Yeah, the change of the length. Yes, it is. I think it's very slowly. Yeah, very slow. Yes, it is just maybe some millimeter or some centimeter in 1 year. So if you use the optic sensor, it is impossible. So in this case, the DINSAR is, I think, is right now is the best one. Yes. Even you use the GPS, yes, the GPS is just the point. Yeah, you can get the just information of the point. Yeah, but if you use the synthetic aperture radar, it is you can get the 3-dimension. Yeah, 3-dimension of the change. It's not just the point of the GPS ground control point. Yeah, but you can also the information of the change in the kecamatan or kabupaten or in the province. Yeah, it is in 3-dimension and high accuracy. Yes, with the accuracy is centimeter or millimeter. Yes, it is just using the differential interferometric SAR. Yeah. Okay, and then and another question. What is question? Yeah.
What are the opportunities for remote sensing in overcoming spatial data problems?
Okay, yeah. Okay, now we talk the problem of Indonesia. Yeah, Indonesia right now is we don't have complete map. Yes, the spatial map of Indonesia with the scale of 1 to 25,000. Yeah, even the scale of 1 to 25,000 is not complete of Indonesia, but now the government have the target that before or until 2024, yeah, we want to complete the map of whole Indonesia with the scale of 1 to 5,000. 1 to 5,000. Yeah, to complete all of Indonesia within now is 2021 in 3 years. Yeah. It is, I think the work is impossible work. Yeah, because if we use the optic sensor, we want to cover Indonesia in 1 year is just 3 months. We can operate the optic sensor. All is cloudy, the cloudy and many cloud. Yes, in just 3 months. 3 times just 3 years. Yes, mean just 9 months. Yes, nine months you must mapping all of Indonesia. Yeah, it is almost impossible, and we need the time to analyze and mapping production. It is a long time. So in this case, is one of the alternative. It's not perfect. Yes, but it is a good alternative right now. Yes, in the world is the synthetic aperture radar. Yeah. Using the synthetic aperture radar, you can operate 24 hours. Yes, all of Indonesia you can map 24 hours. Yeah, so and then 1 to 5,000. Yes, using the synthetic aperture radar. Right now is just the Terasara X. Yes, with the resolution is 1 meter. Yes, and if we use the 1 meter is I think is you cannot realize with the scale of 1 to 5,000 5,000 scale. Yeah. So in this case, is you need the airborne SAR. Yeah. The airborne SAR with the resolution is 10 centimeter. Yeah. 10 centimeter is it is also a challenge. Yeah. I think it's spend much money and time. Yes. Okay. The dream, our target is okay. Yes. We want to realize until 2024. Yeah. Because the president is finished. Yes. 2024. Yeah. So in this case is how to realize this dream. So in this case is we need to operate. Yes. A good sensor. Yeah. Okay. Yes. It is the challenge. Yes. What the challenge in the near future? Yes. It is in the resolution and how to operate to cover all Indonesia, because in the first of my talk is Indonesia is very big. Yeah, to manage Indonesia is spend much money and spend much people. Yes, much brain. Yeah, so in this case is we need many friends. Yes, to solve the problem of Indonesia. Yeah. Okay.
Yes,
Yeah.
some mention this area. Yeah. Well, I got 2 questions more from Zoom room. It is from Reski Anwar from UBB. Yeah. The question is, sea surface temperature or SST can be measured by instrument on the ship or buoys on same spots. However, it can't give information on a wide area or on a global scale. Therefore, we need a remote sensing system which it can be used for SST measurement. This system be able to estimate SST on a larger region and within a short time. How is your solution, Prof?
Okay, yes, synthetic aperture radar working in microwave. So unfortunately, yes, we cannot get the information of the sea surface temperature. And the microwave is when we want to observe the water. Yeah, the water is almost same with the metal. So in this case, we cannot penetrate. Yeah, we can get the information of the surface, but we cannot get the penetrate the water. So in this case, yes, I recommend using the near infrared on the infrared. Yes, I think it's right now is you can get the data almost near real time of the Himawari age. Yes, it is very large. Yes, including the Indonesia. Yes, because in the Himawari is also include the near infrared channel. Yes, and the other one is also you can use the Landsat. I think it's in the Landsat. The last Landsat is have the problem, and next I think it's soon the Landsat the new one is will be launched, and you can get the sea surface temperature. And the other one is also, yes, the MODIS I think you can get, and also the NOAA. Yeah, the NOAA data is also possible. It is free of charge. You can get the data from the Chiba University Center of Environmental Remote Sensing. You can access, and it's free of charge. But the memory is very big. You must prepare the memory, because Every day we save about about 100 tera. Yeah, if you have the 100 tera every day, you can copy. Yeah. And then make the analysis of the sea surface, and you can just cropping. Yes, because the data we also have the data or already in grid data. Yes, from the grid data, you can just cropping which area you want. Yes, for example, the sea surface temperature surrounded of the Bangka Belitung is okay or possible. Yes, you can just cropping and the memory is to be smaller. Yeah. Okay. Yes, can answer. Yeah.
Yes.
Yeah.
I hopefully Rizky Anwar will got the answer from your question. This is the last question, but even though last question, there are two questions. From M. Rudy Wahyono, he is a lecturer at ITB and Ahmad Dahlan, Jakarta. I have two questions to Prof. Josephat. First, could this satellite radar using for monitoring of seismic to predict this earthquake before it happened? The second one, could the satellite radar using for small object like ships, also the change of land elevation caused by development of highway and tunnel for high-speed train, for example?
Okay. Okay. Yes. Actually, for the seismic, yes, seismic observation, yes, we develop several sensor. Yes. One is the here. Yes. We develop this one is the for the electron density and electron temperature. Yes, because it is having the relation with the change of the total electron contents in the ionosphere. Then the TEC or total electron contents have the relation with the the land surface activity, including the seismic activity. Okay, for the I think it's many technique. Yes, now I'm the leader of the disaster monitoring. Yes, in this case, is one of the our member is developed using the GPS RO, the GPS radio occultation, and then we can predict the the activity of the seismic and the earthquake. It is 3 days or 5 days before the earthquake itself. Sometimes in NHK on the TV of Japan is we appear that about our research and about how to predict the earthquake on the seismic itself. Okay, and then the shape observation. Yes, I think it's in my slide. I'm already show you. Yes, we made the experiment. We flew at the northern part of the Makassar, and then yes, we detect it's very small. A shape, and of course the big one is very easy. Yeah, even the small is look like the sampan. Yes, and also the karamba is also we can observe. Yeah, and the other one is the highway and the tunnel and the land deformation. Yes, in the future is I think it's the highway on the tunnel and the land deformation around the infrastructure. We can observe long term. Yes, using this synthetic aperture radar. Yes, but the problem is right now is the orbit. Yes, the orbit coming back. Yes, it is for one place. It is need more than 1 month. So in this case, is we need to launch more than 5. Yes, to get the data every day. Yes, this is very important because when we want to observe the post-disaster, yes, including the infrastructure observation, we need is the continuous observation. If possible, is every day or every minute or every hour at least. Yes, it is. We need to launch more than 5 satellites. Yeah. So in this case, is how to make the satellite is cheaper. Yeah. This is also one of the topic itself. But yes, this is possible. Yes. We can predict the disaster itself. Yes. Based on the some of the relationship of the wave. Yes. And the physical change and the wave itself. Yes. This is one of our research field too. Yeah. Okay. Mungkin could yes answer to Pak Rudi ya.
He will, yeah, I
Yeah.
think so. Hopefully, Pak Rudi will satisfy with the answer of Prof. Yo. And I think this is the end of our question. And then we would like to Prof. Yo to have something like close statement before we close this session. Prof. Yo, if you have a closing statement for this session.
Okay, yes, thank you very much. Yes, first is, okay, maybe just one sentence. Yes, yes, let's, we contribute for the world. Yes, Indonesian people is must contribute for the world. Yes, because Indonesia for the world. Yes, so in this is one of my, message to you. Yes, please bring Indonesia for the world. Yes, contribute on the world. Yeah. Thank you very much. Yeah.
All right. Thank you very much. Give applause to Prof. Yo.
Yeah. Thank you very much, and keep healthy all. Yeah.
We have many students here in this room, and we have also more than 100 participants from Zoom room that are listening to our session today. And thank you again, Prof. Yo. And I'm very sure that a student will understand already that my general question in the first time we open this session, that what is actually microwave remote sensing technology, and we have the answer that, yeah. And I'm sure that anytime you want to ask Prof. Yo, you can send to his email and then to get the answer if you still have a question about this technology. Well, I think that's all from me as a moderator. Thank you very much for your attention, and just forgive me if I made a mistakes during the session. And lastly, the committee will give the certificate for Prof. Yo. Yeah, certificate for Prof. Yo. Okay. It's placard, yeah. Placard for Prof. Yo, but I receive it. All right. This placard is for you, Prof. Yo, but
okay, thank you very much.
Because you are not here, I will represent
Okay.
it.
Yeah. Okay, no problem. Yeah, thank you very much. Yeah.
Is it you will lead or okay? So I think that's all for me. Thank you very much, Prof. Yo, and thank you very much for your attention and for your speech. Very useful and very fruitful presentation. And then I think I have to close this, and I will give it back to Master of Ceremony, Ms. Tini Wulansari. Thank you.
Okay, thank you very much, Mr. Priyoko. So please, for all participants, give applause to our keynote speaker, moderator, and also all of us. All right, so the next agenda, we would like to present the ceremonial gift to the keynote speaker for sharing his expertise in these sessions. So in these occasions, we would like to invite Mr. Priyoko to represent symbolically to receive the plaque and the committee. Yes. In front of maybe, yes. So the plaques and also certificate will be sent to Professor Josephat by the committee. So we would like to invite Mr. Aditya Pamungkas as the host. Yes, to give the plugs to Professor Josephat. So in this case, represented by Mr. Priyoko. All right, thank you. Thank you very much, Professor, for the sharing to all of us. So we will continue to the next agenda. So we would like to present the door prize to 5 students actually in this room who have asked the question to Professor Josephat. So I would like to invite Robi Sugara, Veronica Pasca, Azpari Mahindra, Dimas Rivaldi, and also Fatimah Azahra from Marine Science Department. So please come forward to the 5 students. Okay, we would like to invite Ibu Eva Utami and also Pak Aditya Pamungkas to give the door prize to the students. Ibu Eva Utami is the head of Marine Science Department. Yes. Okay, thank you very much, Ibu Eva Utami, and also Mr. Aditya. So, ladies and gentlemen, before we end our meeting today, our agenda today, so we from the committee would like to invite you all to have a photo session. So in this room, we invite the moderator, of course, the host, especially Mr. Aditya Rahman, and also Ibu Eva Utami. Oh, Aditya Pamungkas, I'm so sorry. Okay, Mr. Aditya Pamungkas, and also Pak Hamsani. Yes. And also the lecturers as the guest today. Yes. And also, maybe you have to wear your mask first and then you can open it later. Okay, for the keynote speaker and also the guests as well as participants in the virtual room. So please prepare for the photo session. The committee will capture the photos several times, page by page. All right, you may open up your mask. All right, thank you very much to the guest, our guest today. So, Alhamdulillah, with this gratitude being expressed, we now come to the end of the agenda on the International Seminar 2021. So thank you for your participations, ladies and gentlemen. All the best to you. So let me close the agenda. Bunga mawar bunga melati. Indah dilihat harum baunya. Cukup sekian acara internasional seminar hari ini. Semoga bermanfaat bagi semuanya. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih semuanya dan jaga kesehatannya ya. Mudah-mudahan nanti bisa berkunjung ke Bangka Belitung. Ya.
Terima kasih Prof. Jo.
Terima kasih semuanya.
Terima kasih.
Mohon izin live ya, saya harus mengajar UNS.
Silakan Bapak.
Selamat siang.
Mohon izin juga
Mohon izin.
semuanya panitia.
Bangga aku jadi alumni UBB karena Pak Pri pakai pengantar. Bener lah. Bangga jadi alumni UBB. Kalau belum mulai. Nempel aja dia Photoshop ya. Buat yang biasa menjadi tipe. Nah, ya perlu tukar nih, dikit generasi. Ada? Ya, kalau udah cukup mana kan? Pagi gitu. Oke, terima kasih banyak. Berarti bukan moderator luar biasa, udah moderator